Hello, my dear students. Welcome to BYJU'S exam prep. Hope you guys are fine. So, guys, let's be quick and join the session fast so that we can start early. And let's take a target that in coming 1 to 1.2 hours, basically 1 hour or maximum 1.5 hours, we will complete the entire formulas of environmental engineering. So, come on, guys, be quick, quick, quick so that we can start faster and faster. Before that, let me tell you a few things that first of all, ये देखो गलत लिख दिया यहाँ पे. First of all, if you don't know about me, you can go through my profile. Next, you can join my Telegram group for further upcoming classes. And guys, you can download the BYJU'S exam prep app. Link is there in the description, in which we are taking classes regularly. And guys, formula revision series is going on. Today's environment. Tomorrow at the same time, Abhinav Negi sir will be taking soil mechanics. After that, surveying and then RCC. Apart from that, guys, we are having 28 marks series going on. So today, sir has taken your 24th January. Sir has taken, Reader sir has taken the session, and tomorrow, that is analytical aptitude, I'll be taking at 10 a.m. After that, Dheeraj sir will be taking on 26th of January. Then I, then Dheeraj sir, and this alternate things will be there. Okay, good evening, everyone. And apart from that, guys, we are having today's 24. So today we already had a workshop if you are targeting for GATE 2025, how to secure a single digit rank. And guys, on this coming 28th of January, we have a scholarship test. Flexibility of timing is there. You can give the test anytime between 9 a.m. in the morning to 9 p.m. in the evening. And we are having an All India Open Mega Mock Test going on from 27th of January to 2nd of February. You guys can check out, give the test and know your All India ranking. And guys, we have launched full syllabus course for GATE 25 and 26. So if you're targeting for the upcoming GATE examinations, you guys can enroll for that as well. Okay. And 28 mark series, I told you that tomorrow will be the class for analytical aptitude. Okay. So come on now. Shall we start now? Shall we start? Shall we start now? Just I want a green flag from you guys. Quick, quick, quick. Shall we start? Quick, quick, quick. Shall we start, guys? Yes or no? Guys, share the session with, and guys, tomorrow we are having analytical aptitude, and tomorrow we'll be having a 2 hours of class. Let me tell you once. Right now that the clash was there, because of that I have to complete it in 1 hour 15 minutes. But tomorrow we are going to have a 2 hours of classes, and trust me, moderate to tough questions will be there. 1 2 easy questions for making you happy this time, but otherwise moderate to tough questions. So be prepared for that. Okay. Now we'll talk just the most important topic which you should not miss. Quality parameters of water, suspended solids, hardness, alkalinity, MPN, and treatment of water, sedimentation, filtration, disinfection. I'm telling you last moment topics which you need to revise first, and don't dare to miss this topic. In distribution systems, go for pipe appurtenances, quality parameters of sewage, BOD, COD, and THOD, biochemical, chemical, theoretical. In design of sewers, partial flow and full flow conditions, those formulas. In the case of disposal of sewage effluents, go for Streeter-Phelps equation. In treatment of sewage, activated sludge process, trickling filter and oxidation pond. And in air pollution, pollutants, primary pollutants, secondary pollutants, plume. And in solid waste management, disposal methods. So I have told you the most important topics, which don't miss it while you are revising. Okay, so obviously environment is a vast thing. So I've told you selective topics which you need to study. Okay, now coming to directly the formulas, guys. So first formulas which you get it, that is for fire demand. If you talk about the first chapter, that is water demand. So in that, the formulas which you get first is for fire demand. So the formula for fire demand first is by Kuchling's formula, that is 3182 root P, where the population you will substitute it in thousands. Example, if 2 lakh is the population, so you will not substitute 2 lakhs, you will divide it by 1000 and you will substitute it here what? 200. Okay, so you will substitute it here, you will get the discharge in liters per minute. Freeman's formula, it is 1136 P by 10 plus 10. As I told you, again, in every formula, P is population in thousands, discharge is in liters per minute. One more case, guys. I have told you this before also. If it is 1135.5, that time you will take here P by 5 plus 10. That time you will take it here P by 5 plus 10. Otherwise you won't. Okay, remember that. Then National Board of Underwriters formula. Guys, if the population is less than 2 lakhs, the formula is 4367. 4637. 4367 or 4637, guys? National Board of Underwriters formula. Is it 4367 or 4637? I made you solve it, so don't tell me that I haven't taught you. 4367 or 4637? Come on, guys. Lashya, Yukta, everybody. Prince. Good. 4637 root P 1 minus 0.01 P. Here also the discharge will be in liters per minute you will get, and the population is in thousands. One more formula, till now they have not asked, but if in GATE they want to ask, as per IS code. As per IS code, fire demand is given by 100 root P. I told you here the fire demand you will get it in kiloliters, and here the population will be in thousands. Here the population will be in thousands. Okay, here the population will be in thousands. So put the population in thousands and you will get the fire demand in kiloliters. Okay, prior to 2012 we used to use 97 root P. Right now we use 100 root P. So this is the formula for fire demand. This is the formula for fire demand. 100 root P. Correct, Saurabh. Now, next is maximum daily demand and maximum hourly demand. Maximum daily demand means out of 365 days in a year, there will be one day when the demand of water will be maximum, which you call it as maximum daily demand. It is given by 1.8 Q. Ma'am, what is Q? Q is annual average daily demand. That means that P population requires how much amount of water in one day, that is known as annual average daily demand. If one person requires 200 liters of water, 5 lakh people will require how much? So 5 into 200. Okay, so that is what annual average daily demand. Here I have denoted by Q. This is not a hard and fast denotion. Okay, maximum hourly demand. Out of that one day, out of 365 days, there will be one day when the demand of water will be maximum. And in that day also, there will be 1 hour when the demand of water will be maximum. That will be known as maximum hourly demand. Technically, it is maximum hourly demand on maximum day. Clear? So here, 1.8 I have done now. Already 1.8 is here. Just check it out. So this will be equal to 1.5 times MDD. So from here you will get, just substitute the value of maximum daily demand. You will get 2.7 times annual average daily demand. Okay. So MDD and MHD. If I ask you generally which is greater, MDD or MHD, what will be your answer? Which is greater, MDD or MHD? Maximum daily demand or maximum hourly demand? Of course, maximum hourly demand. Because, like example, today is what day? 24th January. Okay. Now, out of 365 days from 1st of January to 31st of December, if 21st January the demand of water is maximum, even in 24th January, out of 24 hours, there will be 1 hour when the demand of water will be maximum. So, it's maximum hourly demand on maximum day. So, of course, it will be more as compared to maximum daily demand. Okay. Now, if you talk it about that, we have pipes, we have service reservoirs. So generally when you talk it about distribution system, the water from the service reservoir, when it is supplied to you, so that distribution system is designed for which value? So you will calculate MDD plus fire demand and you will calculate MHD. Whichever comes to be maximum, that will be the distribution system. Don't worry, in the question they will ask you, they will mention, if they are asking you to calculate fire demand, they'll mention by which formula this has to be mentioned. And if they're not mentioning you any name of the formula, they will write as per IS code. So if they write as per IS code, basically you have to apply 100 rupee only. Clear? Okay. Explain what again? What should I explain again? You want me to explain it in Hindi or you want me to explain it in English? See, maximum daily demand means out of 365 days from 1st of January to 31st of December, there will be one day when the demand of water is maximum. Let us suppose that day is 24th of January. Now, in 24th of January, out of 24 hours, because one day consists of 24 hours, so in that 24th January also, out of 24 hours, there will be 1 hour when the demand of water will be maximum. So that hour on the maximum day is known as maximum hourly demand. So maximum hourly demand on maximum day. Clear? I told you now. Okay. So distribution system, maximum of both of them. Now, if you talk about population forecasting methods, what you are doing is you are predicting the population. Okay, because obviously when you design canals and all, you will design it for, let us suppose, for 10 years, 15 years, 25 years. So you need to predict the population. So now you can ask me that, ma'am, why you're not designing it for the existing population? It's pretty much sure that next year India will hit increase the population. So mine, if I'm designing it for the current population, that is pretty much sure that the coming year, the population will increase and my water distribution system will not be able to fulfill the requirements of the people. So it will become the failure of the engineer. That's why we forecast the population. We predict the population. Okay. So first method in this is arithmetic increase method. So PN, I'm writing just once because for every other case it is same only. PN is the population after n decades for which you are forecasting. Decades means 10 years. One decade is equal to 10 years. Population after n decades. P naught is the last known population as per latest record of census. Census means Janganna. In Hindi you call it. After every 10 years you will see they come to your home. How many are male? How many are people? How many are female? How many are employed? How many are educated? All those things. So that is census. So last known population as per latest record of census. N is the number of decades and X bar is the average increase in population. Okay, so here Pn is equal to P naught plus Nx bar. Pn is the population after n decades. P naught is the last known population which you know. N is the number of decades and X bar is the average increase in population. This you use it for old cities where rate of growth of population with respect to time is constant. Now what they can give you in the examination, they will not give you that use arithmetic increase method. They can write predict the population or forecast the population assuming rate of growth of population with respect to time is constant. So if they are telling you the assumption, that means they are asking you to calculate by arithmetic increase method. So if they want to play smartly, they will not tell you that use population arithmetic increase method. They will tell rate of growth of population with respect to time is constant, forecast the population. That means you have to apply your brain, we have to go for arithmetic increase method. Okay. Now talking about geometric increase method, this you use it for rapidly growing city or young city. Means like if let us suppose a new city is being formed, New Delhi initially, New Bhopal, New Chandigarh, New Raipur. So these are what initially it was a young city. So for rapidly growing city or young city, we go for geometric increase method. We go for geometric increase method. This is given as Pn is equal to P naught 1 plus R by 100 to the power n. See, if you are putting R in percentage, then divide it by N. If you are putting R in decimal, then don't divide it by N. Because if you see handbooks and all, you get confused. So that's what I'm telling you. And what is R, ma'am? This is percentage rate of growth. Percentage rate of growth. In the case of geometric increase method, you assume percentage rate of growth is constant. In the case, so don't get confused, guys. In arithmetic increase method, you assume rate of growth of population with respect to time is constant. In geometric increase, you assume percentage rate of growth is constant. Okay. Now, if you want to calculate R, there are different methods of calculating. Like, see, If P2 I want to calculate, this is P1, 1 plus R to the power n. So from here, let us suppose if 1 marks question comes in the examination and they will give you final population, initial population, number of decades, everything. And it is asking you percentage rate of growth. Just calculate it from here. Just check it out. This is what they have done. P2 by P1 minus 1 root over to the power 1 by n. Simple as that. Okay, so you can do this. Fine. Now, the two methods of calculating is, one is arithmetic method, arithmetic mean method. Now, don't get confused. I'll tell you, if I am to make paper, now I'll confuse in this things only to you guys. Arithmetic mean method and this is geometric mean method. There are two ways in a broader sense by which you can calculate percentage rate of growth. If in the question they haven't mentioned you to by which formula calculate percentage rate of growth, you will calculate by this method. Because as per IS code, they have mentioned to calculate basically percentage rate of growth by this method. But practically in the field, I told you that engineers use this method because from here the value of R comes out to be more. Okay, so remember, now don't get confused. Arithmetic increase method is a method of population forecasting, while arithmetic mean method is a method to calculate R. So there is a difference between both of them. Okay, there is a difference between both of them. Now, talking about the next one is incremental increase method. But before that, don't get confused. Here, this N is for number of decades. One patent mistake which you guys do. This is for number of decades. And this N is for number of rates. How many R is there? That much will be there. So number of rates. Okay. Then you have incremental increase method. This is used for moderate, like arithmetic gives you a lesser value of population forecasting. Geometric method gives you a higher value of forecasting. So incremental increase gives you a moderate value of population forecasting. So Pn is equal to P naught plus Nx bar plus N plus 1 by 2 Y bar, where X bar is again average increase in population. And how much increase has taken place in average? That is Y bar. Average of incremental increase. This is Y. Similarly, if you want to calculate decrease growth rate method, what I told you, the population is increasing, but the rate at which population is increasing is decreasing. Like I told you that example of chapati. Initially, I was eating 2 chapatis, then I start to eat 4 chapatis, and then I start to eat 5 chapatis. The amount of chapatis are increasing, but initially the increase was 50%. Now the increase is how much? 20%. So the chapatis are increasing, my diet is increasing, but the percentage at which my diet is increasing is decreasing. So exactly here, the population is increasing, but the percentage at which the population is increasing is decreasing. Clear? So this is decrease growth rate method. I told you don't go through the formula. This formula is very long. Rather go through the simple logic. Okay. Now, I told you logistic curve method. This one I already told you. This is the S curve. Okay. At T0, T1, T2. At T0, the population is P0. At T1, the population is P1. And at T2, the population is P2. I told you one thing. Logistic curve is valid when? Come on, guys. Answer me. Logistic curve is valid when? Logistic curve is valid when? Very good, Anwar. T2 is twice of T1. And all calculations are done from the base year. Every calculations, all this is valid only out of all the population forecasting method. It is valid only in logistic curve method that all calculations are done from base year. All calculations are done from base year. All the calculations. Okay. Now, what is the formula? If you want to forecast the population, generally I don't write this formula. I told you to remember this one. 1 plus m e to the power nt, because this won't be possible for you to calculate in the calculator, right? So P is equal to PS 1 plus m e to the power nt. And what is PS? PS is the saturation population. Saturation population. What is this? 2 P naught P1 P2 minus P1 square P naught plus P2 P naught P2 minus P1 square. Okay, P naught, okay. So at T is equal to 0, P naught T1 P1 T2 P2. So this you have done it. Okay. Now M is a constant, which is saturation population minus initial population at T is equal to 0 divided by initial population. N is again a constant, 2.3 T1 log base 10. Guys, if you don't want to use log base 10, you can use this formula, 1 upon T1 natural log P naught PS minus P1 P1 PS minus P naught. Okay, this is the formula which you can use. Fine. So this is the formula which you can use. Now, obviously, if you want to use log base 10, you have done 2.3. That's it. Nothing else. Clear? So this is the simple formulas which you can apply and you will get the answer. I have put everything in decades everywhere. If I am putting decades here, so I'll put decades here also. So every time all calculations from base year. Remember that. Okay. Now, talking about quality parameters of water. Okay. Any doubts from the first chapter? Now we have done with the first chapter, all the formulas. Any doubts? Quick. Hello, Prithvi. Any doubts from the first chapter, guys? Is my speed okay? Am I going fast? I just want one thing to know from you. Is my speed okay? Is my speed okay or am I going fast? Okay, na? Okay, fine. Now, talking about quality parameters of water, we have three types of broader sense: physical water quality parameter, chemical water quality parameter, biological water quality parameter. Now, when you talk about physical water quality parameters, physical is something which you can touch, feel or see. So first physical quality parameter is turbidity. Turbidity is basically the extent to which light is either scattered or absorbed. So you have four methods in this: turbidity rod, Jackson's turbidity meter, Bailey's turbidity meter and nephelometers. Can you tell me out of the four, only one is a field method? Which is a field method for calculating turbidity? Turbidity is the extent to which the light is either scattered or absorbed. More the suspended solids, more the turbidity. Lesser the suspended solids, lesser the turbidity. How to get 30 marks in 10 days? I'll tell you how to get 30 marks in 1 day. Okay, wait for 1st of Feb or 3rd of February. Very good, Yukta and Anwar. Turbidity rod, only field method to get instant turbidity, that is turbidity rod. Okay, you put that rod, aluminium rod, platinum needle one, you will get the answer. So turbidity rod is the field method which is used for measuring turbidity. Jackson's turbidity meter, you use it for natural water bodies because it gives you turbidity more than 25 units. Generally, turbidity more than 5 units, you are basically visible by naked eye only. So why to use Jackson? So for natural water bodies, you do it. Bailey's turbidity meter and nephelometers are there. They can give you turbidity less than 1 unit. Bailey's turbidity meter and nephelometers are based on current matching technique, because here while doing the measurement, you do the matching of current. Okay. Now, nephelometers, generally nowadays we put formazine in 1 liter of distilled water and you check it out how much color is imparted. So the unit I told you this, again I'm repeating this question: mg per liter, ppm, NTU, FTU. Which one is the most appropriate, guys? I want the answer once again. Which one is most appropriate? Come on. किस चीज का यूनिट कन्वर्जन बता दूं अमित? FTU. Why? Because the principle involved was of formazine. So formazine is the correct one. Remember that. Colors. Okay. The equipment which we use for doing the measurement is known as tintometers. The tubes which we use is known as Nessler tubes. And the chemical which we use, that is we put 1 milligram of platinum cobalt in the form of chloroplatinate ion. So the color which will be imparted will be 1 TCU. TCU stands for true color units. Remember tintometers, equipment, instrument, and the tubes are Nessler tubes. Then talking about taste and odor. Taste and odor, we take it, obviously there are two different physical parameters, but we take it one because the thing which imparts taste also imparts odor and vice versa. Okay, so the equipment which is used for measurement of taste and odor, that is generally odor, because you cannot taste the water if it is specifically if sewage is there, how can you taste it? So the equipment which is used is osmoscope, and here the unit is to measure the intensity, it is threshold odor number. So threshold odor number means here A plus B by A. A is the volume of raw water, and in this you keep on adding the distilled water till the time no smell comes. So this is distilled water. Okay, talking about temperature. Temperature range, you keep it around 10 to 25 degrees Celsius, and always remember, whenever you take a sample within 72 hours, means within 3 days do the testing. But why not after 3 days? Otherwise the biological parameters, chemical parameters will change, okay, of the water. So that is the reason, do it within 72 hours. Now talking about chemical parameters, we have what? We have total solids. Total solids, basically dissolved solids is a chemical parameter. Total solids is the summation of suspended solids plus dissolved solids. Suspended solids, you can measure it by gravimetric technique. Take 1 liter of the sample, pass it through filter paper, gravimetric technique, pass it through a filter paper. Suspended solids will retain. Put 104 degrees Celsius for 24 hours. Water will vaporize. You will get only suspended solids. Okay, you will get only suspended solids. Similarly, whatever sample which has passed through the filter paper, whatever solids has passed through the filter paper, take it, vaporize it, 104 degrees, 24 hours, water vapors will go, you will get the dissolved solids. Okay, now talking about TON generally varies from 1 to 3, that is wrong. I'll tell you that. Wait, at the end I will talk about the 11 तक हो जाएगी class. मैं तो 10:30 पे खत्म करने की सोच रही हूँ यार, 10:30 पे पृथ्वी, क्यों मैच है क्या? Okay, so at the end I'll talk about the limits. Right now I'm not talking about the limits. pH will tell you the acidity or the basicity of the sample. pH is given by minus log base 10 H plus ions, where H plus is the concentration in moles per liter. Similarly, if you want to measure pOH, that is minus log base 10 OH minus ion. OH minus ion is again in moles per liter. The summation of pH plus pOH will give you 14. Okay. And if you multiply H plus into OH minus ion, it will give you 10 raised to power minus 14. Very, 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 very important, guys. Only thing which you can make the mistake, kindly substitute H plus and OH minus in moles per liter. What is moles? Given weight upon molecular weight. Given weight upon molecular weight. So this is the this is the one given weight upon molecular weight. Suspended solids only inorganic particles. Suspended solids has both organic and inorganic particles. किसने बोला सिर्फ inorganic है? चलिए. Okay. So this is the number of moles per liter. चलो. ये अनवर and पृथ्वी. चलो 12 बजे तक क्लास लूंगी. चलो अब जिसको रहना है 12 बजे तक रहना पड़ेगा. खुश? और तुम लोग आज मुझे उचका लो उस दिन मैराथन जैसे. लो अब 12 बजे तक क्लास होगी, बोल दिया मैंने. मैं शाम को 4 बजे से क्लास ले रही हूँ, अभी 12 बजे भी होगी, और कल सुबह 10 बजे हम फिर मिलेंगे. खुश? हैप्पी? एक आध क्वेश्चन, अरे भाई क्वेश्चंस करा चुका है मैंने मैराथन में. ये फॉर्मूला रिवीजन है, बाकी लोग भाग जाएंगे. फॉर्मूला रिवाइज कर रहे हैं कि क्वेश्चंस कर रहे हैं? क्वेश्चंस करवा चुका है बेटा. मैराथन क्लास जाके देखो, हर टॉपिक पे क्वेश्चन कराया है. ठीक है, चलो ठीक है. pH आपको बताता है, pH tells you whether the water is acidic or whether the water is basic. How? If the pH falls from 0 to 7, you will call it as acidic. And if it falls from 7 to 14, it is basic. And at 7, it is neutral. Okay, so this is the one. Now talking about hardness. Hardness in water is due to the presence of dust. Hardness पानी में क्यों होता है? बताओ पहले आंसर. Hardness in water is due to the presence of multivalent cations. First of all, cations are positively charged ions. Multivalent means, देखो फिर गलती सौरभ, प्रिंस, सबकी गलती. मतलब nobody tell me correct. Only Giri and Giri has told correctly. Shravan, multivalent cations. Correct. First of all, cations are positively charged ions. I'm feeding it into your mind. Reason I'm not saying calcium and magnesium, because if in the question it is giving you aluminium and it is not telling you to neglect the minor ion concentrations, then you have to consider aluminium also, na? So that's why I'm feeding it in your mind. It's not calcium and magnesium. Predominantly it is due to calcium and magnesium, but that doesn't mean that it is only due to calcium and magnesium. So hardness in water is due to the presence of multivalent cations, those ions which have a valency more than 1 and they are positively charged. Okay. Now, hardness is further divided into two categories. Carbonate hardness, you call it as temporary hardness. Non-carbonate hardness, which you call it as permanent hardness. Carbonate hardness, why? Because it's not given here. कैसे नहीं दिया है? चलो, okay, fine. Carbonate hardness is that hardness which can be simply removed by boiling or by addition of lime. So you just boil it, heat it, or you do lime add, calcium hydroxide, slaked lime. Okay, so you do what? Calcium, magnesium, acha, strontium, ferrous, ferric. There are n positively charged ions and which are multivalent. Okay, so boiling or by addition of lime, like if you add calcium bicarbonate is there. If you heat it, the sign is this one. Okay, it will become calcium carbonate, carbon dioxide and water. Calcium carbonate is a precipitate. It will settle down. You will take the remaining water. So the water will be free from temporary hardness. Similarly, you can do for by addition of lime. Talking about non-carbonate hardness or permanent hardness, non-carbonate hardness or permanent hardness is one. Even if you boil it or even if you add lime, it will not be removed. You have to apply special techniques like zeolite method, like demineralization process, like lime soda method. They will remove the non-carbonate hardness. Okay, lime soda method does not remove 100% of the hardness, while zeolite method and demineralization process removes 100% of the hardness. Non-carbonate hardness, if in the suffix, if the anion portion is chloride, sulfates and nitrates. Again, I'll tell you, hardness in water is due to multivalent cations only. But if in the suffix, if in the anions you are getting chloride, sulfates and nitrates, you will call it as a non-carbonate hardness or you will call it as a permanent hardness. Okay. Now, total hardness, if you want, total hardness, you can calculate by this. Generally, we take calcium and magnesium. If aluminium is there, you will take aluminium also. So whatsoever is the concentration of calcium, that divided by the equivalent weight of calcium and multiply by the equivalent weight of calcium carbonate. When you divide concentration of calcium by equivalent weight of calcium, this will give you the what? This will give you the gram equivalents of calcium. You know, 1 gram equivalent of anything is equal to 1 gram equivalent of any other thing. So how many gram equivalents of calcium are there? That many gram equivalents of calcium carbonate will be there. Clear? So that is the reason you multiply with the equivalent weight of calcium carbonate. So what I said, 1 gram equivalent of anything is equal to 1 gram equivalent of any other thing. So if it is given to you in mg per liter, you need to divide it by the equivalent weight. If in the question, listen to me very carefully. If in the question they are giving you the concentration in milliequivalents per liter, let us suppose they have given you calcium in milliequivalents per liter, then don't divide it by the equivalent weight. Just multiply with the equivalent weight of calcium carbonate. Why, ma'am? Why not? Because if it is giving you milliequivalents per liter, that means it is giving you the concentration of calcium. Let us suppose they are giving you calcium in milliequivalents per liter. That means it is giving you calcium and equivalent weight. It has already done, it has already divided by the equivalent weight of calcium. So you don't need to do it. Okay, you don't need to do it. Okay, they have already divided it. So kindly, when question comes, twice check it out, whether in a hurry that, oh, so easy question, we'll able to do it. Check it out twice, whether it is in mg per liter or whether it is in milli equivalents per liter. That is important for you. Okay, now, if aluminium is there, same thing will be for aluminium. I just told you that generally two things you need to remember. Equivalent weight of calcium is 20. Equivalent weight of magnesium is 12. If they are giving you the molecular weight as 40 for calcium and 24 for magnesium, then this will be the equivalent weight. And equivalent weight of calcium carbonate is how much, guys? Equivalent weight of calcium carbonate? Kitna hai? How much is the equivalent weight? How much is the equivalent weight of calcium carbonate? 100 by 2? 50? अभी 100 बोल रहे थे आप अग्रवाल जी, अभी इक्विवेलेंट वेट पूछा मैंने. चलिए, now alkalinity is basically what? Ability of water to neutralize acid. There are certain ions in water which are capable of neutralizing hydronium ions. So which are capable of neutralizing hydronium ions means H plus ions. So ability of water to neutralize acids. Those ions which are present in water which are capable of neutralizing H plus ions, that is known as what? Alkalinity. So alkalinity, generally there are n number of anions which causes alkalinity, but we take it for bicarbonate ion, carbonate ion and hydroxide ion. If alkalinity in water is due to bicarbonate ion, you call it as bicarbonate alkalinity. If alkalinity in water is due to carbonate ion, you call it as carbonate alkalinity. If alkalinity in water is due to hydroxyl ion, you call it as caustic alkalinity. Again, same copy paste. If you want to measure here also alkalinity, we measure in terms of calcium carbonate. So concentration divided by equivalent weight into equivalent weight of calcium carbonate. Again, same thing, copy paste. Okay. So now you can calculate total hardness. I told you the formula. You can calculate alkalinity. I told you the formula. Carbonate hardness, you will calculate total hardness, alkalinity, whichever is minimum, it will become carbonate hardness. Okay. If total hardness is less, non-carbonate hardness will be 0. Why? Because total hardness is carbonate hardness plus non-carbonate hardness. And if total hardness and carbonate hardness is also total hardness, non-carbonate hardness will become 0. There will be no non-carbonate hardness present in water. If total hardness is greater than alkalinity, I told you carbonate hardness is minimum of total hardness and alkalinity. So carbonate hardness will be equal to alkalinity and total hardness minus carbonate hardness. Carbonate hardness is what? Alkalinity. So this will be the non-carbonate hardness. In question, if 2 marks they ask you to calculate non-carbonate hardness, then also you need to calculate total hardness, then also you need to calculate alkalinity, then also you need to calculate carbonate hardness, then only you can get non-carbonate hardness. Remember very clearly, non-carbonate hardness, you cannot, there is no ready-made formula that you will get the answer. You have to calculate total hardness and alkalinity and then only you will get non-carbonate hardness. Remember that. Okay. Now, this is the one thing. Now somebody was telling me, na, this is the whole chart for the limits. Turbidity 1 NTU and cost for rejection limit when there is no alternate source available up to 5 NTU. Up to 5 NTU you can allow. Color 5 TCU to 25 TCU. This you used to write 1 and 3. If you check out the codal provision, they have written here agreeable. They have written agreeable. Remember that. Okay, now that's changed. TDS, if you talk it about total dissolved solids, up to 500 mg per liter, no alternate source available, 2000 mg per liter. Alkalinity 200 to 600, alkalinity and hardness same, copy paste limits. pH, generally, obviously we know that 7 is the neutral one, but generally we cannot provide 7, that is not possible. So it can be slightly acidic or slightly, it can be basic. So it is 6.5 to 8.5. There is no cost for rejection limit. Here in pH you have a range. Chloride, if you talk it about chloride, 250 mg per liter acceptable limit and cost for rejection limit is 1000 mg per liter. Fluoride up to 1 mg per liter, it is good. It is good. It will help in strengthening of the teeth. It will prevent from dental cavities. Up to 1.5 mg per liter. Beyond that, if it goes, it causes fluorosis. Mottling of teeth will take place, and if it goes beyond 5 ppm, it will lead to bone fluorosis. That means deformation of bones will take place. So fluoride is the one which you should know. Sometimes if the fluoride is less, I told you, some people like who gets cavities, the doctor advised them to use fluoridized toothpaste, because generally cavities takes place because the water which you are drinking in that fluoride content is very less. So by other means you are grasping fluoride for your teeth. Okay, so that's why the logic for that fluoridized toothpaste is this one. Okay, so next time when you purchase it, remember what I said. Okay, if value is lesser than permissible, it's good now. This just I told you this before also. I'm speaking from 4 ppm. Now I think sometime my voice will only go. Okay. When I say 1 mg per liter, Bhaskar, it doesn't mean that 1 mg per liter should be present. It means up to 1 mg per liter. That means it can be 0.9 also, it can be 0.8 also, it can be 0.7 also. When I say cause for rejection limit is 1.5, that doesn't mean deliberately you will add 1.5. It means up to 1.5. So even lesser is there, that's good. Getting it? Got the logic? Okay. Now talking about the different forms of nitrogen, we have free ammonia, you have organic ammonia, you have nitrate, you have nitrate. This is the old limit which is now not being used. Okay, nitrite and nitrate, they have the same limit. I told you free ammonia indicates dash. Indicates dash. Free ammonia indicates less. Ab dekho, Anwar is doing the advertisement of toothpaste. Good. They'll give you money. In BYJU'S platform, you're doing the advertisement. Free ammonia indicates what? Recent pollution, past pollution, what? Recent pollution. Organic ammonia will indicate the value before decomposition has started. Nitrite will give you the value of partially decomposed organic matter. That means organic matter is still present. So that's why nil. You cannot dare to use nitrite, because here what is there? Here what is there? Decomposition is going on. So this is partially decomposition is taking place. Nitrate is what? Complete decomposition has taken place. So 45 mg per liter is what you allow. Here, if the value is more than 45 mg per liter, blue baby disease or methemoglobinemia takes place to the infants. Okay, remember that. Recent pollution. Correct. Free ammonia plus organic ammonia is called as K-Jalal ammonia, or you call it as K-Jalal nitrogen. Okay, these are the ones. Now, if you talk about biological parameters, here you have MPN test. In MPM, you have 3 tests: presumptive, confirmative, and completed. Generally, you don't test for pathogens, rather you test for coliforms, because presence or absence of coliforms in water will indicate the presence or absence of pathogens. Generally, testing of pathogens is tedious and time consuming. So rather than testing for pathogens, you go for testing of coliforms. Okay. Now, here we just want positive things. So generally, when you talk about the codal provisions one, first we add lactose broth. This is the food for coliforms. If gas is produced within 24 to 48 hours, that is the positive test. We'll take that test. We will add lactose green bile broth. Again, the food for coliforms. Again, we'll wait for 24 to 48 hours. If gases are being produced, again, it is a positive one. And then we will go for completed test. Okay, completed test means we'll talk about the final value. Fine. Now, here till now they have not asked numericals from formula based MPN. This is Thomas equation. If in the question they have not given you the table of NPN, but they're asking you to calculate MPN, that means understand that they're talking about Thomas equation. It might be possible. Now you say, ma'am, they haven't given the table. How can we know that they're talking about Thomas equation? It's but obvious. If they're not giving you the table, you have to go for Thomas equation. You don't have any other alternative. Okay. So what is MPN per 100 ml? This will indicate the density of pathogen. This is number of positive tubes into volume of sample in negative tubes into volume of sample in all tubes into 100. This will give you the MPN value. So here you will do the counting and here you will measure the volume. Clear? So this is Thomas equation. Now, apart from that, you have one more technique, that is membrane filter technique. Nothing is there. In a water, you have both pathogens and you have both coliforms. You will pass it through a sterile membrane. A sterile membrane is there. My writing is, I don't know, even I am not able to understand now. It's becoming so cursive. Sterile membrane. Okay. Today, this is going very smooth. Okay. So in water, pathogens is there, coliforms is there. You pass it through the sterile membrane in which pathogens and coliforms both will be connected. You will place it in an incubator for 24 hours, okay, and you will give food of M. endomedium. M. endomedium is the food only for coliforms. Those who will not get food, they will die. Coliforms will get food, they will multiply. You will count the colonies of pathogens, you will count the colonies of coliforms. Counting the colonies, you have done the calibration with the pathogens. So technically you will count the colonies of coliforms, but you will get the number of pathogens. Why? Because you have done the calibration. Calibration means you are relating two different parameters. So although you are counting the number of coliforms, but you are getting the value of pathogens. Clear? So these are the tests. These are the tests. मैम ये total volume है या sample का जो add किया है वो है. ये total volume है sample का. ठीक है, आपने जो लैक्टोज ग्रोथ ऐड किया उसका नहीं है, ये सैंपल का वॉल्यूम है. जैसे एग्जांपल, जल्दी बताती हूँ, नहीं तो अनवर की बात सच हो जाएगी, 11 बज जाएंगे. पॉजिटिव ट्यूब, नेगेटिव ट्यूब्स. अब ये 10 ml वाला सैंपल है, इसमें 3 ट्यूब्स में पॉजिटिव है, 2 ट्यूब्स में नेगेटिव है. सो 2 into 10 ml you will do. Okay, like if 1 ml is there and here it is 4 and here it is 1, so 1 into 1 ml. Got it? Clear, Mohit? So yeah, here you're counting how much volume is there in negative tubes. 5 tubes we take it. ठीक है, चलो. Any doubts in the second chapter? Any doubts in the second chapter? हाँ या ना तो बोलो. इतने सारे लोगों पर कोई बोलेगा नहीं. Any doubts in second chapter, guys? Okay, चलो. Now moving to the third chapter, that is treatment of water. That is treatment of water. Treatment of water, basically, first we calculated the water demand, then we checked for the desirable quality parameter and undesirable quality parameter. Next, we will talk about the treatment of water. Treatment of water, of course, first we go for screening. Screening is done for the removal of large suspended solids or floating matter. And there is one formula for screening, although never ever in the history they have asked it. But this year if they'll ask, then you will tell me that ma'am you didn't told in formula revision. So head loss is calculated by K upon 2G V square minus U square. K is a constant which will depend upon the material of the screen. G is acceleration due to gravity. Generally you place it inclination. V is the velocity through the screens and U is the velocity of approach. Okay, so U is the velocity above the screen, or you can call it as velocity of approach. V is the velocity through the screens. So K upon 2G is 0.0729. This is the one. Okay, now if you talk it about, generally I told you, you go for ठंड है मैम, टाइपिंग करने की हिम्मत नहीं है. अभी 2 दिन से ठंड यहाँ भी बढ़ गई है यार, मतलब ठीक है, बट रूम में नहीं रहती उतनी, बाकी तो ठंड बढ़ गई है. चलिए, हाँ. Then if we have fine screens and coarse screens, generally we opt for coarse screens because fine screens frequent clogging will take place, so head loss increases and we need to do frequent cleaning, so we go for coarse screens. Okay, K by 2G, if nothing is given, correct Shravan and Vikas, it will be 0.0729. Talking about sedimentation, that is the second process. Before that we have aeration also. Aeration is we bring the water in intimate contact with the oxygen so that color as well as dissolved gases are removed. Okay, so that is aeration. You have 4 types: spray nozzle method, cascade aerator, tray tower and diffused air. Diffused air is an artificial method. Generally we go for cascade aeration. 3 to 3.5 steps of RCC are there, concrete. So you just spill the water, it goes into multiple, like here steps are there, it will go by the steps. So what will happen, it will spread into layers, so opportunity of water to come in contact with the air will increase. Okay, Apart from that, after aeration, we have sedimentation. Sedimentation, we have two types. Sedimentation, the hero is specific gravity. The particles will settle down under the action of its own weight. Here you have two types of sedimentation, plain sedimentation and coagulation aided sedimentation. But before that, if you talk about the type of tanks, you have two types of tank. One is quiescent type, the other name of it is fixed type, and one more name is there, fill and draw type. Okay, so question type, fixed type, fill and draw type. Nothing, just put the water for 24 hours, turbulence zero. Whatever particles is there, they will settle down under the action of its own weight, then you can take out the water. 24 hours is the detention time. You design it for maximum daily demand. Minimum number of tanks is 2. Total number of tanks is 3. 2 operational and 1 standby in case any failure of the tanks takes place in that conditions. And here, generally, whatever solids have settled down, you have to clean it. So, cleaning period is 6 to 12 hours. Okay, you can do it manually also and you can do it mechanically also. Continuous flow type tank, you don't make the turbulence zero, but you reduce the velocity of flow of water so that suspended solids settle down. Now here, the flow can be laminar flow, the flow can be transitional flow, the flow can be turbulent flow. If the dia is less than equal to 0.1 mm, you call it as laminar flow. If the dia is from 0.1 to 1 mm, you call it as transitional flow. And if the dia is greater than 1 mm, you will call it as a turbulent flow. The formula which is very important and 99% of the time used is this is the formula. D square upon 18 nu. This is kinematic viscosity, which is dynamic viscosity by density. So D square by 18 nu, Gs minus 1 into G. This is the formula. If in the question it is telling you that consider the effect of temperature, okay, then use this formula. This is an empirical formula. You will get settling velocity in mm per second. You have to substitute dia in mm and you have to substitute temperature in degree Celsius. Remember that. Now, if the flow is transitional, exactly same formula, only differences in laminar D square is there and here D is there. Only difference. Okay. And if it is talking about turbulent flow, it is 1.8 root over GD Gs minus 1. Okay. 99% of the time they have asked you this formula. So kindly remember this formula. Now one more thing, important. I told you that dia is less than 0.1 mm, you have to go for this formula. If many a times, if you check out the PYQs, the dia is more than 0.1 mm. But if it is telling you in the question, assume the Stokes law to be valid. And it is telling you to consider it laminar. Although you know that if the dia is less than 0.1 mm, it is not laminar. But if in the question it is telling you, you have to consider. Okay, you have to consider it. Clear? So make it sure. Use this formula. Don't tell me that, ma'am, you told so we didn't use. But in the question, it is telling you not that assume it laminar. So you have to assume it laminar. You don't have any other options. Okay? So that's the thing. Now, the next one is surface overflow rate. This is the velocity of the design size of the particle. The particle for which you are designing the sedimentation tank. So velocity of design size of particle. Or you can call it as concern side of particle. This is given as Q upon BL. BL is what? Plan area, or you can call it as surface area, length into width of the tank. Now, two velocities are there. I told you one is the flow velocity and one is the settling velocity. Flow velocity is discharge. The velocity is what? Discharge upon area. When you take the velocity, you take perpendicular area perpendicular to that. So, this is the cross-sectional area. This is the cross-sectional area. So VF is equal to discharge divided by cross-sectional area, which is VF, which is the velocity of flow. Clear? Now, if you want to calculate how much, this is not the efficiency, remember that. In the question, they never ask you, they haven't asked you efficiency till now. They have asked you percentage removal. How much removal of the particle has taken place. So V0 is the velocity of concern size of the particle and Vs you can calculate it from here. So Vs by V0 into 100 will give you the percentage removal of the particles. Clear? And if it is the circular tank, this formula, remember they have asked you this in ESE conventional. Okay, so if they ask you to calculate, let us suppose in the case they will give you volume, or they will give you the dia, but they will not give you the volume also directly. They will give you discharge and detention time. So first you will multiply discharge into detention time. You will get the volume. Substitute it here. You will get the dia. So here a cubic equation will be there. So I guess technically they should ask you the height. That will be better. Okay. So they can ask you questions from this topic. Okay. Now, if you are not getting the efficiency by just plain sedimentation, you add chemicals. The predominant, the most popular chemical which you add, that is alum Al2SO4 thrice dot 18H2O. This is the formula I told you. I gave you the trick that easy breezy within a fraction of seconds you can solve questions. So filter alum. Alum requires bicarbonate alkalinity. If alkalinity is not present, alum will not function. Remember that. Bicarbonate alkalinity is mandatory, mandatory, mandatory. If it is not present, काम ही नहीं करेगा, वैसी का वैसी रहेगा, काम ही नहीं करेगा. Okay, so you need to add bicarbonate alkalinity. It will form calcium sulfate. So filter alum, when added, it needs alkalinity. It will form permanent hardness. It will form flock. It will form carbon dioxide, which causes corrosion of pipelines, and it will lead to water of crystallization. Okay, if you want bicarbonate alkalinity, what you need to do is you need to add calcium carbonate. Calcium carbonate plus water will give you bicarbonate alkalinity. If you want calcium carbonate, you need to add quicklime. Quicklime, when react with carbon dioxide, gives you what? Calcium carbonate. Okay, now, here I have done the unitary method and I have told you these formulas. Here the most important one is this two. Very, very, very important. ये मैंने आपको बोला था, and we have done questions also from this. So questions, if you remember, Yukta, Prince, Anwar, you guys were there. So questions where we were able to solve within a fraction of seconds. So these two are damn important, just done by unitary method. So if you need 1 mg of filter alum in 1 liter, you need to add 0.5 mg per liter of alkalinity as calcium carbonate. And if you need alkalinity as calcium carbonate, you need to add, if you need 1 mg of alkalinity, you need to add 0.56 mg per liter of lime. So these two are very important, very, very important. Okay, now coming further. Now, when you are mixing the chemicals, you want that proper mixing to take place. So that's why you use mechanical mixers. You have pedals which is being rotating so that proper mixing of the chemicals takes place. फिल्टर बेड में अभी पहुंचे कहाँ है यार, अभी फिल्ट्रेशन में आए कहाँ है, रुको तो फिल्टर बेड में आने के लिए. Now when you talk about mixing basin, you want that proper mixing should take place. So obviously you need to supply power so that the paddles rotate. So how much power to be supplied, that is given by G square mu V. See, I'm telling you the places where you do mistake. आदत है, your habit, V is for velocity, V is for velocity. Here also you will do that same thing. V is for volume. Remember that. Very important. V is for volume. So P is equal to G square mu V, where V is the volume. Okay. So P is the power which is dissipated in watts. G is the temporal mean velocity gradient. Basically, it is relative velocity with respect to distance. You call it as temporal mean velocity gradient. It will tell you the intensity of mixing. More the G, more the intensity of mixing. V is the volume of raw water in which you are applying the power. Okay, now if you want to know the type of flock which is formed, if you have larger temporal mean velocity gradient and smaller detention time, question from this has already been asked. Okay, if G is more and detention time is less, that means you're keeping the water for a lesser amount of time. Denseness will be there, they will be heavy, but the size will be small. If you are doing small intensity of mixing, but you are giving larger time for the water to be there, so obviously the amount will be more, but their weight will be less. So large and light flocks. Clear? Now, talking about filtration. Filtration. So filtration, what are the formulas important? We are going to that only. Filtration in itself acts like a complete treatment unit. I told you it removes dissolved solids, it removes color, it removes suspended solids, it removes organic matter, it removes microorganisms. So it itself acts as a complete treatment unit. Okay, so the formulas which you need to, generally we have slow sand gravity filters, rapid sand gravity filters. Why the name slow and rapid is given? Depending upon the rate of filtration. In rapid sand filter, the rate of filtration is more as compared to slow sand. That's why the name is written to you. Okay, here the head loss of unexpanded bed and the head loss of expanded bed, both are same. Can you tell me the reason? Head loss of unexpanded bed and head loss of expanded bed, both are same. Can you tell me the reason? Till the time I'll bring water for you. Come on guys, nobody answered. Prince, थोड़ा सा हाथ निकालो बाहर, लिख दो, टाइप करो. अनवर, श्रवण, विकास, Amitesh, come on guys. Why? Head loss of unexpanded bed and head loss of expanded bed are same because buoyant weight of the particles is not changing. So head loss formula is given by D1 minus Ng minus 1. D is the depth of filter media. सीपेज कहाँ से आ गया? कहाँ सीपेज? तो buoyant weight की बात कर रहे हैं particles की. So buoyant weight of the particles is not changing. So head loss is given by D1 minus N, G minus 1. D is the depth of filter media, N is the porosity, and G is the specific gravity. Okay, head loss of expanded bed. D dash 1 minus N dash G minus 1. Both of them are same. So head loss of unexpanded bed and head loss of expanded bed, that is same. D1 minus N, G minus 1. D dash expanded depth, N dash is the expanded porosity. Ab N dash say or Ne say both means the same. That is VB upon Vs to the power 0.22. This is an empirical equation. VB is the backwash velocity. Settling velocity का formula आपको दे रखा है. ठीक है. So these are the important formulas in filtrations which you need to know. Concentration नहीं होता, buoyant weight of the particles. अब आ जाएगा. तुम लोग अभी अब ऐसा कर रहे हो, मुझे तो गुस्सा आ रहा है बहुत तेज. मैं क्या करूं बताओ? क्या करूं मैं? तुम ही लोग मुझे बता दो. Tell me. I'm triggered with anger because you know that in environment starting from gate 2021 they have never ever asked any single numerical MSQ question. So it's damn sure that they will ask you obviously theoretical question, and they will ask you that head loss of unexpanded bed and expanded bed remains same due to no change in the buoyant weight of particles. आप तो false mark करके आ जाओगे क्योंकि आपको तो पता ही नहीं है. बताओ, अब आज ये क्लास नहीं होती तो तुम तो मार्क करके आ जाते अगर ये क्वेश्चन आएगा और फिर मेरे ऊपर नाम लगाते, मैम यू डिडंट टोल्ड मी. बताया तो है. कितनी बार बताऊं? बता दो मुझे, कितनी बार बताऊं मैं? हाँ, लॉसेस की बात कहां से भाई? जो हेड लॉस हो क्यों रहा था? कौन से ये डेरिवेशन देखोगे तो बाइट हम लोग इक्विलिब्रियम ऑफ फोर्सेस की बात कर रहे थे. सो वेदर इट इज एन अनएक्सपैंडेड वन और इट इज एन एक्सपैंडेड वन, बाइट वेट इज नॉट चेंजिंग, राइट? सो व्हाई द हेल हेड लॉस विल चेंज? सेम रहेगा. अब डी वन माइनस एन जी माइनस वन करो, डी डैश वन माइनस एन डैश जी माइनस वन करो, यू विल गेट द सेम वैल्यू फॉर श्योर. रिमेंबर, जब तक मैं डांटू ना, जब तक तुम लोग मुझे गुस्सा नहीं दिला दो, तुम लोग को चैन नहीं आता. 4 बजे से हो गया, बोल रही हूँ तो आवाज भी मुझे खुद की नहीं सुनाई दे रही है. फाइन, अब डांट पिटी अब दिमाग में रहेगा. अब तो मेरे ख्याल से कभी नहीं भूलोगे. फाइन. लास्ट, disinfection. Disinfection is the process of killing pathogens, disease causing microorganisms. Disease causing microorganisms. Generally, we don't go for disinfection because it is not possible that you select and kill the disease causing microorganisms. Rather, you go for sterilization. You kill all the microorganisms. In that process, disinfection will take place. Okay. Now, when you talk about chlorine will function only when the pH is greater than 5. If the pH is less than 5, it will remain as molecular chlorine. HOCl. HOCl means hypochlorous acid. It is 80 times more powerful as compared to hypochlorite ion. HOCl. pH if greater than 8, it will become hypochlorite ion and H+. If it is less than 7, it will remain hypochlorous acid. Okay. HOCl is so reactive that the will form, it will kill all the existing microorganisms. Okay, it will kill all the existing microorganisms. Now, if you talk it about at pH 5, you will get molecular chlorine only if pH is less than 5. Okay, if pH is 5 to 7, you will get only hypochlorous acid. If pH is 7 to 8, you will get hypochlorous acid and hypochlorite ion. If pH is greater than 8, you will get only hypochlorite ion. Okay, now if you talk it about this is a very important formula based on this question has been asked. Ratio of hypochlorous acid to hypochlorous acid plus hypochlorite ion. This is equal to 1 upon 1 plus K upon H plus. This is the formula. Kindly remember it. Okay. Now, talking about Chick slot. Very, very important. If you check out the PYQs lot of times and in consecutive years they have asked question. What is the formula? NT is equal to N naught e to the power minus KT. Nt is equal to N naught e to the power minus Kt, where N naught is the number of microorganisms at T is equal to 0, Nt is the number of microorganisms at any time T, K is the disinfection constant and T is the time. Okay, this is one formula. Second is, if you want same percentage killing of this, I haven't told you because never ever they have asked this. फिर मुझे लगा बता देना चाहिए. Okay, in case if they ask you. If you want, you are changing the temperature, but you want that same percentage killing of bacteria should be there. Like if initially it was 90% killing of bacteria, now also you want 90% killing, but you are changing the temperature. So what should be that temperature or what should be the time? So if T1 degree Celsius, let us suppose T1 was the time. At T2 degree Celsius, T2 was, small T2 was the time. So this is the formula log base E, T1 by T2, E by R. This is for time and this is for temperature. T2 minus T1, T1 into T2. So this is the formula by which, if in case ever, till now they have never ever asked, but if they ask you this formula, this is the formula by which if you change the temperature, but you want the same percentage of killing of bacteria, you can use this. Clear? So this is one of the things. R is universal gas constant, E is the activation energy. Remember, temperature you will be substituting in. Okay. Now, last thing is dose. How much dose you should provide? ये तो water softening मैंने भी already बता चुका है. Dose. How much dose, or you can call it one more thing is there, applied chlorine. Applied chlorine. Applied chlorine is how much demand of chlorine is there and how much residual chlorine is there. Ma'am, why do we want residual chlorine? Because we want to protect the water from future recontamination. So that is the reason you add chlorine in such a manner that after a contact period of 10 minutes, you should have at least 0.2 mg per liter of chlorine remaining as residual chlorine. Okay, so that is the reason. So applied chlorine is equal to what is the demand plus residual chlorine. Got it? Water softening I have already told you, and this completes your third chapter. Any doubts? Any doubts? Any doubts? मेरा phone होने वाला switch off. जल्दी बोलो, any doubts? नहीं है? चलो. Then we will talk about distribution and conveyance system. In distribution and conveyance system, we have four types: dead end system, gridiron system, radial system, ring system. Dead end system is also known as tree system. Gridiron system is also known as interlace system or reticulation system. Gridiron system is used for planned cities. Dead end system is used for a city which is developed in a haphazard manner. Gridiron system has a large number of walls which is being used, but you can fulfill the fire demand. Here, apart from that, if any maintenance work is going on, you can get the water from other places. While in dead end systems, water gets stagnated. If you are not getting the water from one place, you don't have any other alternate source. Fire demands cannot be fulfilled, while in grid system it is done. Ring system is also, you can get all the benefits of gridiron system. Radial system, generally when large number of radial roads are there. So you have a distribution reservoir. So that water can be supplied at all the places. Okay, so this is the distribution reservoir. This is the radial system. Now talking about methods of distribution, either by water will move under the action of its own weight, or you will pump the water, or the combined gravitation and pumping, which is generally used from the treatment plant to your that pani ka tanki service reservoir. It is pumping, you lift the water, okay, and from that pani ka tanki, from that service reservoir to your homes, it is gravitational, that is under the action of its weight. So by combined gravitational and pumping system. Clear? Chalo. Next, we have storage capacity. We have balancing storage, equalizing storage, and fire storage. Can you tell me what is breakdown storage? मैं फोन चार्ज में लगा के आ रही हूँ, मेरे फोन में बिल्कुल चार्ज नहीं है. Come on guys. मैं गई, तुम लोग को आंसर ही नहीं करना, मतलब ऐसा लग रहा है मुझे मैं स्कूल की टीचर हूँ अभी, और मैम गई है तो चलो थोड़ा चाय स्नैक्स कर लेते हैं और कुछ खाना नहीं है. मेरे पास टैबलेट है, मैं टैबलेट से भी देख सकती हूँ तुम्हारे कमेंट्स. ठीक है. Providing calamity situation. Breakdown storage is, let us suppose electricity failure takes place. Breakdown pump failure takes place. Any operation maintenance work is going on. So that time water will be not coming from the treatment plant to the service reservoir. So in that case, you need, for such conditions, you need to store the water. Okay, then you have balancing storage or equalizing storage. See, your demands will vary. जैसे अब अभी आप मुझसे पढ़ाई कर रहे हो, ठीक है, अभी आप मुझसे पढ़ाई करो, तभी आपकी पानी की डिमांड होगी नहीं, क्योंकि आप मुझ पे और जो मैं पढ़ा रही हूँ उस पे फोकस कर रहे हो. यू आर फोकसिंग ऑन मी एंड व्हाट आई एम टीचिंग. सो नाउ मे बी यू आर नॉट ड्रिंकिंग वाटर ऑल्सो, सो राइट नाउ योर डिमांड इज लेस, बट the supply has to be constant. So the supply has to be such that your variable demand is getting balanced. Sometimes your demand will be more than the supply, sometimes your demand will be less than the supply. So balancing storage or equalizing storage is the one in which you are balancing the variable demand with constant supply of water. With constant supply of water. This is known as balancing storage, or you call it as equalizing storage. Here, this is the supply line and this is the demand line. So generally it is mod of A plus mod of B. So if here demand is more, supply is less. So cumulative demand minus cumulative supply, whatever is maximum, plus here the supply is more, demand is less. So cumulative supply minus cumulative demand max. Clear? So this will give you the this will give you the storage capacity. Now, if you want, just I'm telling you these 4 points. If they ask you detection of leak in underground pipes, and they will give you these 4 options: only A, only B, or they can ask you an MSQ. So that's why it should be there in your head. You can directly see if there is wet patches on the land. You can see that leakage is taking place. By sounding rods, you can check it out. You will plot a hydraulic gradient line. If a kink is there, if you're plotting the line and a kink is there, that means somewhere leakage is taking place. Or you have waste detecting meters, by the help of which you can check it out that underground leakage is taking place or not. Okay, so these are the methods. Just know the name. Dhyan rakhna. Okay. Now talking about pipe appearances, this they can ask you in different manners. They will give you the name of the valves and they will give you the you can say the functions they will perform. Match the following, or they will give you the function and they will give you 4 options. Identify the type of valve. So this question is not much popular in GATE, but very popular for ESE and your state level examinations. But if they want an MSQ, they can ask you this, because this is one of the statement wise questions. Okay, so sluice valve or gate valve, or there's one more name, cutoff valve. These are used to regulate the flow of water. Okay, so proper regulation when you're stopping the flow, water hammer effect should not take place. For those reasons, you place the sluice valve. Generally, you place it at the summit point. The reason for placing it at the summit point is the pressure to be resisted is less. Ma'am, so what if pressure is resistant? You can use a moderate quality material. Now, if it has to resist a large amount of pressure, that time you need to have a durable material. Otherwise, you can go for a moderate material also. Okay, air valve or air relief valve. I told you technically there are 2 types of valve: air relief valve and air inlet valve. When excess of pressure is there, of air is there, more than the predetermined pressure, you have air relief valve, or you call it as air release valve, so that excess of pressure goes out. If the pressure is less than the predetermined pressure, negative pressure will come. Okay, and if negative pressure will come, that is also a problem. So you place air inlet valve so that excess of air from the atmosphere will come, and it will make the negative pressure, it will compensate the negative pressure. So air inlet valve is also there, and air release valve is also there. Both are placed near to the gate walls. Okay, then you have reflex, bursting and crushing failure. Very good, Shravan. Then you have reflux wall. You call it as check wall, or you call it as non-returning wall. We don't want the water to flow in the backward direction. Otherwise, failure of the pumps or damage of the pumps can take place. So these walls are installed so that the water flows only unidirectionally, only in one direction. Apart from that, other walls are there. The most important one was this one: first, second, third, and this one, fourth. The ones which are many times asked: scour wall, blow off wall, drain wall. If any, because obviously when water is coming, it will carry the sediments with itself, and the sediments will deposit on the pipeline. So time to time you need to do with the cleaning also. So you have these walls, these are manually operated. So over in time, when you do the maintenance work, what you do is, air walls are automatic in nature. Air walls are automatic in nature. Reflux check walls are also automatic in nature, because हम थोड़ी ना बार बार देखेंगे pressure कितना है air का. You don't do that, right? So that is why. Now, when you talk about scour wall, blow off wall, or drain wall, so these walls are used to remove the sand silt particles if they are there. These are manually operated. Okay, time to time when you do the cleaning, you just place it. Then you have foot wall. You don't want that any foreign impurities or debris should come. So foot wall. Butterfly wall, globe wall, same function. Remember, function is same, mechanism is different. Sluice wall, gate wall, cutoff wall, butterfly wall, globe wall. All of them has the function to regulate the flow of water. Only thing is mechanism is different. Then needle and cone valve is there. Ball float valve. I told you about floating. You have it in your home syntax पानी का टंकी also, and in your water cooler नहीं, वो जो आपका ये जो कूलर होता है यार, जो गर्मी में यूज करते हैं, दैट समर सीजन कूलर, दैट वन कूलर, वाटर कूलर नहीं बोल रहा, कूलर, ठीक है, दैट कूलर. So there also you have this float, that is a very light size material, so that it can allow a predetermined water only, not more than that. Okay, so there you have it. Pilot valve, जहाँ पर भी wherever you have high pressures, you use this. Flush tanks also you have it, yeah. Pilot valves, you use it in places of high pressure. Stop cocks, generally you have that wash basins and all, there you use it. Water meters, whenever you want to measure the quantity of water, at that position you place this water meters. Just like you have electricity meters, same place as in that same pattern you have water meters also. Fire hydrant, wherever whenever you need to supply water for the outbreak of fire takes place, so you have an outlet which is provided. So you might have seen that firefighting people, that is placed near to the main water, so that they connect that pipeline to the fire hydrant, and then they get the water. Okay, so wherever main pipelines and all are there, there's this fire hydrant being placed. Okay, so these were the distribution and conveyance system. Any doubts? Any doubts? जल्दी बताओ, फिर हमने नेक्स्ट चैप्टर करना. अभी वेस्ट वाटर कैरेक्टरिस्टिक्स, अभी ट्रीटमेंट बचा है, डिस्पोजल बचा है. जल्दी. एनी डाउट्स? कम ऑन गाइस. चलो, 10 बजने वाला. 10 क्या, 11 भी बजेगा, 12 भी बजेगा. घड़ी कभी पीछे जाती है क्या फ्रेंड्स? वो तो हमेशा आगे जाती है, वो तो बढ़ेगा ही. दैट आई ऑल्सो नो. प्रेशर मत दो मुझे, ऐसा उड़ा के पढ़ाऊंगी ना, पूरा उड़ जाएगा. चलो. Sewage. What is sewage? Sewage is a mixture of water and liquid waste which is being generated due to various activities. In sewage, generally more than 99.9% is water and less than 0.1% is solid. Okay. Now talking about domestic sewage. Domestic sewage is generated due to domestic activities, cooking, washing, cleaning, all those things, domestic activities, whatever sewage is generated, that is domestic sewage. Whatever sewage is generated due to industrial activities, you call it as industrial sewage. Generally, you say sanitary sewage is the summation of domestic sewage plus industrial sewage. Okay. Now talking about sullage. Sullage. Whatever waste is generated from bathrooms and kitchen, that waste is termed as sullage. Okay. So sewage is a mixture of water and liquid waste generated due to various activities. It consists of 99.1%, 99.9% more than that water and less than 0.1% solids. Sullage is generated due to the waste generated from bathrooms and kitchens and all. Okay. Now talking about dissolved oxygen. If dissolved oxygen, the amount of oxygen which is present in dissolved format in water. Dissolved oxygen is dependent on temperature. With increase in temperature, dissolved saturated, yes, more organic content in sullage. Organic content in sullage, उसमें कोई fruit pills वगैरह है? चलो, deosaturated. Saturation dissolved oxygen. Maximum quantity of oxygen which can be dissolved in water at a given temperature is known as dissolved oxygen. This is constant for a particular temperature. I was asking, as the temperature increases, deosaturated will increase or decrease? As the temperature increases, deosaturated will increase or decrease? बताओ, deosaturated will increase or decrease? Decrease करता है. Henry's law क्वेश्चन आए एग्जाम में. Henry's law पे. As the temperature increases, solubility आज मैं बोल पाऊंगी कि नहीं अब आगे. Check, mic check. I guess my voice is clear. Fine. Now tomorrow, I guess at morning 10 you'll be hearing a bad voice. Fine. Deosaturated is saturation dissolved oxygen. As the temperature increases, the solubility of oxygen or any gas in water will decrease. This is as per Henry's law. Okay, deosaturated at 20 degrees Celsius is 9.2 mg per liter. Clear? Now, if you want to calculate dissolved oxygen, I'm just telling you the name of the experiment is Winkler's method. Winkler's method is used for testing the dissolved oxygen. Clear? The chemicals which are used is manganese sulfate and alkaline potassium iodide. Clear? Now if I talk you about chemical oxygen demand, it is the amount of oxygen required for the decomposition of biodegradable and non-biodegradable organic matter. Okay, here you put chemical. Can you tell me the name of the chemical? That is Cr2C2O7. So technically chemical oxygen demand, you call it as dichromate demand test. Okay, you call it as dichromate demand test. Only in chemical oxygen demand, just remember the name of the indicator. Ferroin is the indicator which you use it in chemical oxygen demand. So it is the total amount of oxygen which is required for the decomposition of both biodegradable and non-biodegradable organic matter. Theoretical oxygen demand, on pen and paper you are assuming that complete decomposition of organic matter is taking place, whether it is organic or whether it is biodegradable or whether it is non-biodegradable. Okay, so if you talk it about THOD is greater than equal to COD and it is greater than equal to BOD ultimate. What is that? In COD you talked about biodegradable and non-biodegradable. In THOD also you talked about biodegradable and non-biodegradable. In case of biochemical oxygen you demand, you talk only about biodegradable organic matter. So biodegradable organic matter, the amount of oxygen which is required for the decomposition of only biodegradable organic matter is termed as BOD. So generally we take 5 days at 20 degrees Celsius as standard BOD because more than 2/3 decomposition takes place. Okay, so because ultimate BOD will take infinite time. So now if you want to calculate BOD at any time t at any temperature, this is the formula. Ultimate BOD 1 minus e to the power k t degrees Celsius into time. Okay, if you want to calculate at any other temperature, the deoxygenation rate constant K20 1.047 T minus 20. Generally nowadays, if you see the past year question papers, they don't expect you to remember this. Instead of 1.07, generally they write it as theta. theta is temperature coefficient. So nowadays they give you the value of temperature coefficient. Okay, don't worry, in the question if they will give you deoxygenation rate constant, they will tell you. If you see the old years paper, that time they were not telling you. Now if you see the last 5 years latest paper, they will mention whether it is base E or whether it is base 10. So don't worry whether to apply this or whether to apply this. Okay, and if you want to calculate the BOD at any time t, how much is remaining? So this much is remaining. Okay, and 5 days BOD if you want to calculate, DO initial minus DO final into dilution factor. Ma'am, how can you calculate initial and final DO? By Winkler's method. Okay, dilution factor is how much time the sample is diluted, kitna pani milaya aapne. This is equal to volume of sewage plus volume of water divided by volume of sewage. Question में generally nowadays they say 2% solution, 4% solution. कुछ दिमाग मत लगाओ, 100 by x%. This will directly give you the value of dilution factor. Clear? Now 1.056 for less than 20 degrees Celsius. Yes. तो इसलिए मैंने आपको बोल दिया कि generally they will mention you. पर एक 1.014 भी होता है. So nowadays they just mention you the temperature coefficient theta value. Okay, now if let us suppose there is the volume of sewage and there is the dissolved oxygen of the sewage. In that you are adding water for diluting it, and here you are the dissolved oxygen of water is there. So now the dissolved oxygen of initial has become DO mix. So what it will be? Volume of sewage plus DO of sewage, volume of water into DO of water divided by volume of sewage plus volume of water. Okay, so this is again one formula for calculating DO mix. क्योंकि अब पानी में हो गया मिक्स, अब सीवेज में मिक्स हो गया पानी. ठीक है, चलिए. Now this is important, population equivalent and relative stability. Population equivalent, just as I told you, it is not possible to calculate directly that how much industries is generating pollution. So we measure in terms of with respect to, in proportion to how many people they are generating the pollution. So it is total demand or total industrial waste BOD divided by BOD produced by per person per day. In GATE, 99% chances there that they will give you the BOD produced by per person per day. But if in the question it is not giving you, it is 80 grams per capita per day, or you can write it as 0.8 kg. अब देखो ये standard है. If in the question, अब कुछ लोग ऐसे महान लोग हैं, अब मैं क्या ही बोलूं, अब हंसोगे आप लोग, you laugh. There was one question in test series. I told you that standard BOD is 80 grams per capita per day. In that question, it was 75 grams per capita per day. Question it is written. But why do you guys write 80 grams per capita per day? I told you na, generally, if nothing is mentioned, take this value. पर भाई जब question में दिया तो वो value लो ना. Take that value. अपना दिमाग क्यों लगा रहे हो? And फिर बोल रहे मैम you told this thing, and then he is sending me the screenshot and telegram, मैम you told this thing, देखो मैंने वही किया, नहीं आया. Read the question, पे किया तो सही है, फिर मैंने question दोबारा पढ़ा. 75 grams per capita is given, then why the hell you are writing 80? Remember that thing, ये stupidity है. ये silly mistake भी नहीं बोलूंगी, that is literally a case of stupidity. So just remember that. Getting it? If nothing is mentioned, take 80 grams. ये ESC में होता है generally when nothing is mentioned. GATE में generally 99.9% of the time they'll mention it. Okay? So जो mention है उसको use करो. Remember that. Now, talking about relative stability. Relative stability is basically how much oxygen is present in the effluent, whether it is dissolved oxygen, whether it is molecular oxygen, divided by how much oxygen is required for the decomposition of first stage carbonaceous organic matter. अगर आप BOD और इसका diagram देखो, तो पहले stage में the decomposition of, you call it as first stage BOD, you call it as carbonaceous BOD. Then second stage BOD, or you call it as nitrogenous BOD. The amount of oxygen required for the decomposition of nitrogenous organic matter, उसको बोलते हो nitrogenous BOD. First stage BOD किसके कारण होता है? यहाँ पे heterotrophs does the decomposition. ये आ चुका है question gate में. And second stage BOD is done by autotrophs. Heterotrophs utilizes organic carbon, autotrophs utilizes inorganic carbon. Inorganic carbon, for taking out that inorganic carbon, it takes time. So that's why before autotrophs take out the inorganic carbon and does the decomposition, heterotrophs has done its function. Okay, relative stability, there is two formulas, 101 minus 0.794 T 20 degree Celsius, 101 minus 0.604 है, देखो ये गलत है, अब बताना, 604 है, T 20 degree Celsius and T 37 degree Celsius are time required in days for the decolorization of methylene blue colored solution when incubated at 20 degree Celsius and 37 degree Celsius respectively. Very good, Shravan. 0.630 है, ध्यान रखना है, ठीक है, चलो. Any doubts in this chapter? Now we have moved to the sewerage system. Sewers की designing करेंगे. Any doubts? Now we have moved to the sewerage systems. We have three types of sewerage system. The sewerage system is what? Distribution, conveyance, transportation. Basically everything is being done through this only. So we have separate sewerage system, combined sewerage system, partially combined या partially separate बोल देते हो sewerage system. Separate sewerage system, you have two different pipes for domestic sewage or basically sanitary sewage and storm water. Storm water is that water, बारिश का पानी, okay, which is flowing onto the surface. Generally that water which is there from the storm, it carries only inorganic particles. It carries only inorganic particles, right? So if you have two different pipes, one is for this barish ka pani, storm water, you call it as drainage, and one is for sanitary sewage. That is domestic sewage plus industrial sewage. You have two different pipelines, you call it as separate system. If you have one pipelines for both of them, you will call it as combined system. Partially separate is the water which is collected in the rooftop of your building and courtyards and all, that water you will allow it in the sanitary sewage pipe. Apart from that, whatever other rainwater is there will go to the storm water pipe. That is known as partially separate, because it is practically not possible that whatever water is there in the rooftop and all, you can collect it. Clear? So that is the reason. Talking about, this is the designing question, don't worry, they'll mention you in the question. If P is the population, now check it out. If in the question X is per capita water supply, then total water demand will be P into X, which you call it as small q, take it. Okay. Then you will assume that 70 to 80% whatever water is supplied will convert into wastewater. In GATE, they will mention you, so there is nothing like assuming. This is for ESC conventional. If in the question, rather than giving you per capita water supply, if they give you sewerage water supply, okay, then there is no need for 70 to 80%, because already in the question it has given you the sewerage water. Okay, dry weather flow, this is the sanitary flow. You take the factor of safety, basically you design it for branch sewer. I told you if nothing is mentioned, you have lateral sewer, branch sewer, main sewer, outfall sewer. You design it for branch sewer. So you take 3 times the value. Okay, now here you have storm water also. Storm water is given by, if you want to calculate the discharge, this is the rational formula, 1 by 36 K PCA. K is the runoff coefficient, which is the ratio of runoff by rainfall. PC is the critical rainfall intensity in centimeter per hour. Remember, this is very important. यहाँ पे गलतियां करते हो. A is the catchment area in hectares. I don't know why you put kilometer square. It is in hectares. Remember that. Critical rainfall intensity will not be given to you in the questions generally directly. So it is the function of time of concentration. What is time of concentration? Time taken by the farthest or the remotest point of the water molecule. Time taken by the water molecule from the remotest point to reach to the outlet. तो उसको आप बोलते हो time of, जो time उसको लगा, the time which it has taken, that is known as time of concentration. It is the ratio of channel flow time या time of entry plus time of flow. ठीक. If time of concentration is 5 to 20 minutes, 75 Tc plus 10. Time of concentration, put it in minutes. If time of concentration is greater than 20 minutes, put 100 Tc plus 20. Okay. So here you will get the answer directly in centimeter per hour. Yeah. Now, apart from that, there are empirical formulas also, like Dickens formula CD A to the power 3 by 4. Remember, here A will be in kilometer square. Rives formula, again here it will be in kilometer square. One thing, if you forget 3 by 4, 3 plus 4, 7. Dickens also, Dickens, 7 alphabets. Rive 2 plus 3, 5. Rives also 5 alphabets. So don't forget. Total discharge will be dry weather flow, that is the sanitary sewage plus storm water. So this will give you discharge. Discharge is equal to area into velocity. In the question, if they ask you dia, discharge you have calculated, velocity will be given, you will get the dia. Clear? Now, there's one more formula, self-cleansing velocity. Generally, you know that we design sewer for open channel flow. That means the water will be flowing under the action of gravity. So you design the sewers in such a way that if any silting, first silting should not take place. And if any particles has settled, it will carry out the cleaning of that particle. So that velocity should be maintained in that minimum velocity should be maintained in the sewer. So the formula is given by 1 by n r to the power, ये dp na niche hai, you'll get confused. Let me write 1 by n r to the power 1 by 6. R is hydraulic radius, which is the ratio of wetted area to the wetted perimeter. K, dp is the particle size, gs minus 1 whole ki power half. This is the formula. N is Manning's roughness coefficient. Okay, and dp is the particle size. Gs is the specific gravity. Now this is again important. English formula भी बता दूं. चलो English formula बता देती हूँ. Dickens formula is valid in northern parts of the country. Rives formula is valid in Andhra Pradesh, Tamil Nadu parts of the country. English formula is valid in Western Ghats of Maharashtra. This is the formula. English. It's I, not E. So English formula. Clear? चलो लिख दिया. लिख भी देती हूँ. English formula. Western Ghats of Maharashtra. ठीक है? चलो. Now it's not generally necessary that the water will be flowing half full. Obviously it can flow less than half full. So full depth is equal to the diameter of the sewer and partial depth is equal to small d. So if you want to calculate, alpha is the angle which is being subtended. So small d by capital D is equal to half 1 minus cos alpha by 2. Okay, so the partial depth to the full depth. Area of this wetted area to the full area is alpha by 360 minus sine alpha by 2 pi. Perimeter, small p to capital P is alpha by 360. Velocity is capital N by small r by capital R to the power 2 by 3. ये याद रखना, ये याद रखना, ये याद रखना. Velocity discharge अपने आप बन जाएगा. कैसे बन जाएगा भाई? Velocity तो आपको पता है ना, 1 by n r to the power 2 by 3 s to the power half. कैपिटल भी पता है ना, 1 by n r to the power 2 by 3 s to the power half. बस ऑलरेडी r आप निकाल ही सकते हो. स्मॉल r बाय कैपिटल R क्या हो जाएगा? स्मॉल a बाय स्मॉल p, कैपिटल A बाय कैपिटल P. तो दिमाग में क्यों, why to remember more formulas? Just remember these three formula. That's it. Don't expect to remember more formula. 123 a नहीं है, रूट a है. रूट a आएगा. ठीक है? So just remember these three formula. That's it. बाकी you can calculate. निकाल लोगे. Now this is important. अगर कभी डेटाबेस आ गया, जनरली आई डोंट एक्सपेक्ट मच डेटाबेस थिंग्स. वेलोसिटी ऑफ फ्लो इज मैक्सिमम व्हेन जो d by d जो रेशियो है, डेप्थ ऑफ पार्शियल फ्लो टू फुल फ्लो डेप्थ इज 0.81. इफ डिस्चार्ज वेलोसिटी अगर मैक्सिमम चाहिए, सो स्मॉल d by कैपिटल D पुट 0.81. डिस्चार्ज इफ यू वांट मैक्सिमम पुट स्मॉल d by कैपिटल D 0.91. ओके, अगर मैनिंग्स एन कांस्टेंट है and they're asking you the ratio of they're asking you the ratio of velocity. So that is small b by capital V, small r by r to the power 2 by 3. You'll use this. Okay. Agar by chance self cleansing velocity is the minimum velocity. अब ये question ना theoretical बन के आ जाएगा. ठीक है? Even they can ask in MSQ, take the correct statement questions. So कहाँ से आते हैं लोग यार, क्या बोलूं मैं, पूरा फ्लो बेकार. Okay. Minimum velocity requirement in sewer is not satisfied. What you can do is या तो increase the slope को बढ़ा दो, so that see if the slope is like this, water will flow with a smaller velocity. If you will increase the slope, water will flow at a higher velocity. So if the minimum velocity you are not able to maintain, increase the slope or increase the dia of sewer. Okay, do it anyway. Fine. चलो अब अगर आपको equal degree of self cleansing velocity, one statement answer me. If you want equal degree of self cleansing velocity, dash should be same. Can you tell me what should be same? मैं फोन लेके आती हूँ, चार्ज हो गया होगा. If you want equal degree of self cleansing velocity in two different sewers, dash should be same. क्या है वो dash बताओ. डैश शुड बी सेम. अब देखो फिर नहीं बता रहे हो, अब फिर स्टेटमेंट आई जाएगा, फिर मुझसे डांट खाओगे. हाँ, श्रवण सेड इट. अब ये प्रिंस को पिटेगी पिटाई. पढ़ने यही आना है, पर फालतू बातें भी यही करनी है. चलिए. शेयर स्ट्रेस शुड बी सेम, है ना. अब प्रिंस याद रखेगा, आज इसको सब लाइव डांट पिटी है. फाइन. सो shear stress should be same. So bigger pipe, small pipe, gamma RS, gamma RS. We assume density of sewage and density of water approximately same. So from here, R by small r will become equal to small s by capital S. Clear? So shear stress experienced by them is same. तो यहाँ से ये फॉर्मूला हो जाएगा वेलोसिटी का, ये फॉर्मूला होगा डिस्चार्ज का. ये रिमेंबर करने की कोई जरूरत नहीं है, जस्ट रिमेंबर द वेलोसिटी वन, बस और कुछ. ठीक है. चलिए. नाउ अब हम बात करते हैं डिस्पोजल ऑफ सीवेज की. एनी डाउट्स फ्रॉम द प्रीवियस चैप्टर? डिस्पोजल ऑफ सीवेज, ट्रीटमेंट ऑफ सीवेज, एयर पोल्यूशन, सॉलिड वेस्ट मैनेजमेंट. 4 बचा है. रोलो रोलो. चलो. Disposal of sewage, you do it by dilution or you just do it on land. Disposal, obviously it will depend upon, generally disposal by dilution, you do it in rivers, lakes, seas and oceans. Okay, you just put it in a large water body which has exponentially high amount of discharge. It depends upon dilution factor. Dilution factor is volume of sewage plus volume of water divided by volume of sewage, which I have already told you. This remember in case if they ask you, if dilution factor is more than 500, no treatment. 3 to 500, plain sedimentation is required such that suspended solid should not be more than 150 mm. If it is 150 to 300, secondary treatments and all need to be done. If it is less than 150, pura treatment karo. A to Z. Royal Commission, they gave this. आजादी से पहले का चल रहा है. Okay. Now talking about zones of pollution in rivers, we have different zones. Zone of degradation, active. This is the chronology. It works in this manner only. Zone of degradation, zone of active decomposition, zone of recovery, zone of clear water. Initially when you dispose the sewage, so this is the river which is flowing and this is valid only for rivers. ध्यान रखना, मतलब क्या है भाई, मैंने पूछ लिया zone of pollution in lakes, आप यही आंसर दे रहे हो. लिखा है ऊपर, रिवर में ही होता है ये, ध्यान रखो भाई साहब, भाइयों और उनकी बहनों, ध्यान से सुनो. ये सिर्फ और सिर्फ रिवर्स में वैलिड है. दिस इज वैलिड ओनली फॉर रिवर्स. इट इज नॉट वैलिड फॉर लेक्स, इट्स नॉट वैलिड फॉर सीज, इट्स नॉट वैलिड फॉर ओशंस. Okay, so when you are disposing the sewage in a river, what will happen? Initially the water will become dark and turbid. Immediately the dissolved oxygen will fall to 40%, means 60% is exhausted. Fishes will be there, algae will die. Zone of active decomposition, highly pollution. DO may fall even to 0. Water will become even darker. Okay, fishes will also die. Zone of recovery, maximum demand has been satisfied. The level of DO will again rise to 40%. But it will never go up to DO saturated. Zone of clear water, here what you will see that again it has gone to DO saturated. Fishes, algae, everything are alive now. Again the water has been purified. So this is the zone of pollutions, and by this method water will purify, river water will purify itself on its own. Okay, now obviously when you mix the sewage into the river water, so now you will get the DO mix and you will get the BOD mix. Discharge of sewage, DO of sewage, discharge of river, DO of river upon discharge of sewage plus discharge of river. Discharge of sewage, BOD of sewage, discharge of river, BOD of river upon discharge of sewage plus discharge of river. दो चीज बस मुझे यहाँ पे बतानी है. If sewage is highly polluted, ये word लिखा है. If sewage is highly polluted, this word is written. DO of sewage will become how much? If sewage is highly polluted, DO of sewage is क्या होगा? बोलेगा नहीं क्वेश्चन में. You have to apply your brain. It will not tell you in the question. Highly polluted, oxygen is exhausted, 0. You have to apply your brain. If river is fully saturated with dissolved oxygen, that means BOD of river is 0. If no fully saturated means whole oxygen is present. Why? If deosaturated there means no organic matter is there. So if no organic matter is there, BOD will be zero. Remember this. Okay, this both the things. Now this is the value. I already told you as the temperature increases, BOD value will decrease. Already written. Sorry, BOD value, DO value will decrease. Okay, chale. These are some of the standards. If you are disposing into the rivers, make sure that 5 days BOD should not be greater than 20. If you are disposing in sewer, not more than 100 mg per liter. If you are disposing it on land, not more than 500 mg per liter. Okay, so these are just basic guidelines. This is the one thing. Streeter-Phelps equation. So first, मैं बना लूँ. So this is deoxygenation rate constant Kd. This is reoxygenation rate constant Kr, and this is the resultant. So if you want to calculate the deficiency of oxygen after T days, what is the formula? This is the formula Kd upon KdL upon Kr minus Kd 10 raised to power minus Kdt minus 10 raised to power minus Krt plus D naught into 10 raised to power minus Krt. Kd is deoxygenation rate constant, Kr is reoxygenation rate constant, D naught is the initial DO deficit, which is equal to DO saturated minus DO mix. DO mix क्या होता है? I just told you before. Now if you want to calculate, ये critical कर लेती हूँ और इसको at time T any is there, जिसको आप DT बोल रहे हो. Critical is when critical DO deficit is when the maximum, उससे ज़्यादा deficiency हो ही नहीं सकती. Okay, that is the maximum deficiency which can be possible. So you will get the critical deficiency at critical time. So that critical time is given by 1 upon Kd F minus 1 log 1 minus F minus 1 DO naught by L into F. L is not here the length. This is the ultimate first stage BOD. Remember this. Length mat mark karke aa jana. Ultimate first stage BOD. F is purification factor. Self purification constant also, which is the ratio of Kr by Kd. Okay, now if you want to calculate, अब दो तरीके, one this one is there, one this manner is there, और एक और है formula में यहाँ पे लिखा नहीं है, L by F 10 raised to power minus Kd Tc. This is the formula. So if in the question it is asking you to calculate critical DO deficit, one formula is this, by which you can calculate critical DO deficit, and one formula is this, with the help of which you can calculate critical DO deficit. Okay, L by F 10 raised to power minus Kd Tc. This formula looks small, but remember Tc you have to calculate by this formula. And remember that you have to do it in virtual calculator. So when you are doing it, make sure that you apply proper brackets because nazar hati durghatna ghati. So even one wrong thing and your whole answer will become wrong. So remember, ma'am told you this when you, if Streeter-Phelps question come, ma'am told you to do a proper check on the brackets. Remember that. Okay, sure. Any doubts in the disposal of sewage chapter? Now we have gone to the third last chapter, that is treatment of sewage. Any doubts? Any doubts? Sure. कितनी खुशी, बट अब लग रहा है 11 तो फिर भी बचेगा. Okay, now let's talk about treatment of sewage. Treatment of sewage, when you talk it about, first raw sewage is there. You pass it through screens where large floating matters are being removed. Then you part it through grid chamber. In grid chamber, inorganic suspended solids like sand, silt particles are removed. Then you pass it in a skimming tank where oil and grease particles are removed. Then you pass it in a primary sedimentation tank where organic suspended solids are removed. Then you pass it in a biological treatment where organic dissolved solids are removed, and then you pass it in an SST. Okay, this is the whole process. So now already I told you about screens, large floating matter, grid, inorganic particles are removed, skimming tank, oil and grease particles are removed. So now we will directly go to the 12 तो नहीं बजेगा, कुछ भी कर लो, अभी मेरे से लिखवा लो ब्लैंक पेज में, 12 तो मैं बजने ही नहीं दूंगी, मेरा वादा है आपसे. Now, biological treatment, we'll go for trickling filter. Trickling filter is a aerobic because here decomposition will be done in the presence of oxygen, and this is an attached growth mechanism. Attached growth mechanism means you will give the microorganisms a medium for the attachment of biomass, attached growth mechanism, and then the decomposition will be carried out. So here, मुझे theory तो पढ़ानी नहीं है. Okay, so this is the attached growth mechanism. First, you are giving time for the microorganisms to get attached in the filter media, and then you will be carrying out the decomposition of organic matter. So this is the formula of efficiency. I mean, ये formula use किया. Generally, what we have done already in the marathon 1 plus 0.0044 U, where U is organic loading rate in kg per day hectometer. Okay, if you want to do it in terms of volume, in terms of cubic meter, तो मैंने आपको बताया था 100 1 plus 0.44 U. U is kg per day per cubic meter. Okay, here F in case of standard rate trickling filter, F is 1 because recirculation ratio is 0. In the case, if they ask you efficiency, that is influent BOD minus effluent BOD divided by influent BOD into 100. So there are two formulas for calculating efficiency. Influent, this one and this one. So you can compare in case if they ask you to calculate volume. So दोनों को compare, just compare it, you'll get the volume. Okay, now this is for low rate trickling filter, or you call it as low rate नहीं बोलते, generally you call it as standard rate trickling filter. Here you are not doing any recirculation, so recirculation ratio is 0, recirculation factor is 1. I told you before also, remember recirculation ratio, some people denote it by R only, which is QR by Q naught. That is recirculation ratio. Recirculation factor is denoted by F, which is 1 plus R upon 1 plus 0.1 by R whole square. This is recirculation factor. Kindly read the question carefully. Recirculation ratio is given or recirculation factor is given. Galti karoge, whole answer will be wrong. Remember that. Okay. Now, अब इसने से यहाँ पे Li लिया. Generally, what we take the denotation is S naught and S. For influent BOD we take S naught. For effluent BOD we take S. Okay, and we are recirculating a part of it. Chalo. Oxidation pond. It itself acts like a complete treatment unit. Suspended solids, digestion of sludge, everything it does. Drawback, large area of land is required, 0.5 hectares to 1 hectare. Minimum 2 हफ्ते चाहिए होते हैं. Minimum large detention time, minimum 2 weeks. Generally 20 to 30 days. Depth 1 to 1.5 meters. Organic loading rate, the rate at which organic matter is loaded into the pond is 300 kg per hectare per day. Detention period, if you talk it about, अब ये important है. पूछा नहीं है, but अगर पूछ लिया तो detention period 1 upon kd log based in L upon L minus y. L is that BOD which is going into the pond and Y is the BOD which is removed. ध्यान रखना, यही गलती करते हो. This is important. Y is that BOD which is removed. अब जैसे L, the one which is going is 300 mg per liter. The one which is coming is 30 mg per liter. So don't put 30. Remove कितना हुआ है? 300 minus 30, 270. So this will be Y. That is the only mistake you can do it here. ठीक है. चलिए. Our favorite activated sludge process, ASP. I have told you, in any unit, if you don't put secondary sedimentation tank, it will not cause much impact. But if you don't put it in ASP, AXP will not at all function only. I told you, so this is the system which we talk it about. Okay, Q naught is the discharge, S naught is the influent BOD, X naught is the microorganisms. Here S is the BOD which is coming out. We assume, this is our first assumption, KD is the oxygenation rate constant half. We assume that no removal of BOD takes place in SST. I have already told you in actual it takes place, but here we are assuming that no removal takes place. Okay, so Q naught XU. इसमें कुछ चीजें गलत लिखी है. QU is the useful sludge concentration. Out of that useful sludge, a part of sludge is recirculated and a part of sludge is wasted. Okay, and this will be QE, which is Q naught minus QW. Okay, so I'll explain you the diagram first, फिर तो easy everything. Q naught is the discharge which is going, S naught is the BOD which is going, and X naught is the microorganisms going. This is V, the volume of the aeration tank. Okay, in the decomposition will take place. The sludge will settle here. A part of the sludge will be recirculated back. It has a high concentration of microorganisms XU, and the BOD will be S. S is the BOD which is being removed. Okay, we assume that no BOD removal has taken place in SST. So here also S, here also S, here also S. Everywhere you will get S only. Clear? And this is the sludge which is wasted. You have taken it to sludge thickening tank, to sludge digestion tank, and then to sludge grind beds. Now here you have a few parameters which you need to remember. First is the aeration period, the time for which you are supplying oxygen in the tank. So time is what? Volume by discharge. So volume of the tank divided by the rate of sewage flow in the tank. So volume by discharge. This is aeration period. Food to microorganisms ratio, how much food you are giving. Food means organic matter. So if S naught is in mg per liter is the food, in the whole discharge Q, how much will be the food? Divided by microorganisms. X is the MLSS concentration, mixed liquor, suspended solids. Okay, mixed liquor, MLSS, mixed liquor, suspended solids. Mixed liquor means sewage sample. So if X mg per liter is present, so in the whole volume, how much will be present? So Q S naught upon Vx. So this is the food by microorganisms ratio. How much food you are giving and how much microorganisms is present. Okay, more the food, lesser the microorganisms. Efficiency will be more or less, guys. खाना ज़्यादा है, खाने वाले कम है. Efficiency more or less? Obviously less. Because food is more, it is not getting decomposed. Vice versa. Food is less, microorganisms is more. खाना कम है, खाने वाले ज़्यादा है. Efficiency will be more. So food by microorganisms inversely governs the efficiency. Clear? Good. Now volumetric loading or BOD loading. How much BOD you are putting to the volume of the tank. This is known as volumetric BOD loading or organic loading. Important, sludgeage. The time for which the microorganisms remains in the system, you call it as sludgeage. There's one more name for it, that is mean cell residence time. This will tell you how much suspended solids are there in the system divided by how much suspended solids is leaving the system. अब देखो एक important चीज guys, very important. 95% of the students remember the formula of sludgeage as Vx upon QWXU. Don't do that. Kindly remember this formula. I know maximum times the microorganisms which is going out of the system is zero. So this whole terminology becomes zero. But why you are taking the risk? If in the question they are giving you the XC value, then you don't remember the formula. You remember this formula. You will apply this formula. This will become wrong. So kindly remember this formula. This you use it when XC is zero or XC is neglected. Okay. So that is the reason. Use this formula. Fine. Sure. Next is sludge volume index. I told you by default if nothing is mentioned, then also the unit of sludge volume index is ml per gram. What is the sludge volume index? How much volume is occupied in ml by 1 gram of suspended solids when you allow them to settle for 30 minutes. Generally the suspended solids weight you get it in mg per liter. So when you want to convert it into grams, you will put 10 raised to power minus 3, that will go above. So generally you remember like this. If in the question, अब ध्यान से सुनना मेरी बात, फिर दिमाग से गलती करोगे, रट लोगे VOB upon XOB into 1000, VOB upon XOB into 1000. Remember what I have written here. This is ml, this is mg per liter. If in the question directly they have given you the suspended solids in gram per liter, then don't multiply by 10 raised to power 3. ये भी लिख ही देती हूँ. If they have directly given you the weight in suspended solids, don't write it. Clear? Fine. Now we have sludge digestion tanks. Sludge digestion tank is a process in which we reduce the moisture content. Okay, once we pass it through sludge thickening tanks, then we take it to the sludge digestion tank. We will reduce the volume there. It gets converted into solid liquids and gases. You get digested sludge, you get supernatant liquor, and you get gases. So here basically 3 stages are there. ये sequence है, chronology. This has been asked in some of the exams to arrange it. Acid fermentation, acid regression, alkaline fermentation. Acid regression, first acid formers will come. They will convert it into acids and alcohols of lower molecular weight. In acid regression, you will get supernatant liquor which has high BOD concentration, 1500 to 3000 ppm. You will sand it back to PST. Alkaline fermentation, methane formers will come. Methane formers are pH sensitive. They are very delicate. They work in a narrow pH range of 6.5 to 7.5. Okay, so here the acids and alcohols of lower molecular weight will be fed by methane formers and they will convert it into gases, predominantly methane and carbon dioxide. Generally 65% is methane and rest is carbon dioxide and other inert gases. Okay, here only two formulas are important if they ask you to calculate the volume of sludge digestion tank. So what is the volume which is coming in the sludge digestion tank and what is the volume of sludge which is going? Remember, very important thing. My voice is not coming now. If it is telling you in the question, assume the process of sludge digestion to be linear, then apply this formula. If in the question it is telling you that assume it to be parabolic, then apply this formula. T is the time for which you are carrying out the digestion. If monsoon is there, rainy season is there, you cannot carry out the disposal of the digested sludge. So you have to make extra space so that that digested sludge remains. Ma'am, how do we know? In the question, if they are telling you monsoon period, means they are asking you to include it. So it is V2 into T. Okay. And monsoon storage here also V2 into T. T is the monsoon period. For how many days the monsoon is going on, till that time you have to go. And this T is for digestion period. Digestion period. Okay. Now, septic tank, hem of tank, you already know. Septic tank is an anaerobic suspended growth process. Hem of tank is also an anaerobic suspended growth process. Then it itself acts as a complete treatment unit. You carry out the basically here suspended solids, organic suspended solids are removed, digestion of the sludge takes place, and even organic dissolved solids are being treated. So it itself acts as a complete treatment unit. Generally, it's 12 to 36 hours you provide it. After that, you dispose it in absorption trenches, dispersion trenches and all, and soak pits. Hem of tank is a two-story tanks you provide. Generally, it is 11-14 meters high. You have sedimentation chamber different and digestion chambers different, so that mixing doesn't take place. Okay, so this is hem of tank. Carl Hemhoff was the one who designed it. चलिए, यूनिट ऑपरेशन, यूनिट प्रोसेस, ये आपसे एक मुझे याद नहीं आ रहा ईएससी या गेट के मैच द फॉलोइंग में पूछा है. सो दिस इज इंपॉर्टेंट. यूनिट ऑपरेशन फिजिकल फोर्सेस आर प्रीडोमिनेंट, ये याद रखना. यूनिट प्रोसेस केमिकल फोर्सेस आर प्रीडोमिनेंट, ये ध्यान रखना. किसमें, इन विच ऑपरेशन विच फोर्स इज प्रीडोमिनेंट. दिस हैज बीन आस्क्ड. आई डोंट रिमेंबर इन गेट और इन ईएससी इट हैज बीन आस्क्ड. ओके, चलो. एनी डाउट्स इन दिस चैप्टर? कोई डाउट? क्यू आर बाई क्यू इज इक्वल टू एक्स अपॉन एक्स यू माइनस एक्स, यही तो होता है. चलो, सेकेंड लास्ट चैप्टर सॉलिड वेस्ट मैनेजमेंट. अब इसमें तो कोई फॉर्मूला ही नहीं है. म्यूनिसिपल सॉलिड, you have three types of waste: municipal solid waste, industrial waste, hazardous waste. In municipal solid waste you have garbage, you have refuse और यहाँ पर है ashes. Generally if you want to calculate, यही बस याद रखना है, if you want to calculate the energy in kilojoule per kg, if you want to calculate the energy in kilojoule per kg, it is the energy of each component into 100 minus moisture content. Agar if you don't want dry basis, means you don't want moisture, so you will subtract moisture which is in percentage. If you don't want moisture as well as you don't want ash, so you will subtract the moisture percent and you will subtract the ash percent. Okay. If in the question they are giving you carbon percentage, they are giving you hydrogen percentage, they are giving you oxygen percentage, and they're asking you to calculate, then you can use this formula. Now this formula is old. This was the formula which was used initially, and this is known as Dulong's formula. Okay. 33761428 H minus O8 by 95S, ये पुराना formula हो गया. नया formula आप मुझे बताओगे because I have already taught you this. Okay. In the new formula, nitrogen is also included. This was the old formula. Now we have the new formula for it. Okay, यही formula थे इस chapter में, और कोई formula ही नहीं है, बस यही formula था. Any doubts? कोई मुझे comments नहीं दिख रहे हैं. Refresh. Any doubts? ये पुराना फॉर्मूला है, इसको यूज मत करना. चलो, क्लासिफिकेशन ऑफ एयर पोल्यूटेंट्स. वन थिंग पता नहीं बहुत फेवरेट है. प्राइमरी एयर पोल्यूटेंट्स, सेकेंडरी एयर पोल्यूटेंट्स. Oxides of sulfur, oxides of nitrogen, oxides of carbon, these are primary air pollutants. Secondary air pollutants, when two primary air pollutants combine, or when primary air pollutants in water vapor and in the presence of sunlight combines, it gives you secondary air pollutant. Ozone, H2SO4, PAN, these are secondary air pollutants. Oxides of nitrogen, sulfur, carbon, these are primary air pollutants. Okay. फिर हमें बात करनी थी प्लूम बिहेवियर की. तो ये मेरी गाड़ी बन गई है, ठीक है. एंड दिस इज, सो व्हाटएवर flumes which are being produced, they are the path which is taken by this gases, this is known as plume, and the place from where they are originated, that is known as stack. ठीक है. अब यहाँ पे हमारे पास डिफरेंट टाइप ऑफ प्लूम्स है. पहले मैं आपको बस एक चीज बता देती हूँ क्विकली. लैप्स रेट. लास्ट में क्या डाउट है? लास्ट में क्या डाउट है? लास्ट में क्या डाउट है भाई? फ्लूम इज सो रियलिस्टिक, बहुत ज्यादा, बहुत रियलिस्टिक है. पोल्यूशन ही ब्रीथ कर रहे हैं ना. चलो पहले लैप्स रेट बता देती हूँ, नहीं तो फिर प्रिंस बोलेगा कि मैम को 11 बजे खत्म करना है तो मैम ने बताया ही नहीं. चलो, लैप्स रेट. As the altitude increases, the temperature decreases. The rate at which temperature decreases with increase in altitude, you call it as lapse rate. Environmental lapse rate is when the temperature of the surrounding air decreases with increase in height, you call it as environmental lapse rate. It is not fixed, it varies from place to place. Adiabatic lapse rate is when the temperature of the air parcel or the pollutants decreases with increase in temperature. You call it as adiabatic lapse rate. Adiabatic lapse rate is constant. Generally, you have two adiabatic lapse rate: dry adiabatic lapse rate and wet adiabatic lapse rate. If nothing is mentioned, it is talking about dry adiabatic lapse rate. It takes place below the clouds. It is 9.8 degrees Celsius per kilometer. Wet adiabatic lapse rate takes place above the ground, which is 6 degrees Celsius per kilometer. Okay. Super adiabatic lapse rate is the lapse rate when environmental lapse rate is more than adiabatic lapse rate. That means in both the cases temperature will decrease, but the rate at which temperature decreases is more in case of surrounding air. So this is the one I told you that if you calculate the slope, here you are calculating x by y. So that, remember, so ELR will be more than ALR. Super adiabatic lapse rate, or you call it as unstable environment, because here mixing of pollutants takes place. फिर हमारा आता है, ये दो बार कैसे आ गया, ये सब adiabatic lapse rate. Sub adiabatic lapse rate. In sub adiabatic lapse rate, you call it as stable environment, because here mixing of the pollutants will not take place. So here ALR will be more than ELR. तो ये होता है आपका stable environment. Now ये looping plumes, ये सब के बस conditions याद रख लेना. That's it. Looping plume, loops will be formed. Here ELR will be more than ALR, so it will be an unstable environment. Proper height of chimney should be there. Then if you talk about neutral plume, ALR and ELR is same. Vertical rising of the pollutants will take place. Okay. Coning plume, ये कब take place करता है? Wind velocity should be greater than, wind velocity should be greater than कितना? Coning plume takes place. This is stable. Wind velocity should be greater than, किससे ज्यादा होनी चाहिए? मैं नहीं बताऊंगी, बताओ. कोन लाइक स्ट्रक्चर बनता है टेम्परेचर. अब तुम लोग की पिटाई होगी. विंड वेलोसिटी शुड बी ग्रेटर देन, हंस रहे हो बताओ. विंड वेलोसिटी शुड बी ग्रेटर देन 32 किलोमीटर पर आवर, तब बनेगा कोनिंग फ्लो. Fanning plume, ऐसे the plume will spread horizontally. Extreme inversion condition. Inversion means with increase in altitude, temperature also increases. That is known as inversion. ALR हमेशा ALR will always decrease. ALR temperature will always decrease with increase in altitude, but in ELR temperature increases. Inversion is happening. So in extreme inversion conditions, you get fanning plume. The best plume is lofting plume. First, you have inversion and then you have super adiabatic lapse rate. So pollutants will be not crossing this inversion layer. So here this is the most good condition, best condition for us. Opposite, if it happens, inversion takes place afterwards, then it becomes the worst condition, that is fumigating plume, because the pollutants will remain inside near to the earth's surface. So that is very, very brutal conditions, because pollutants will be there and we will be inhaling that. So the best is lofting, worst is fumigating. In lofting, first inversion, then unstable. In fumigating, first unstable and then inversion. Trapping plume, here actually unstable or super adiabatic above also, super adiabatic below also, and in between. So inversion first also, inversion at last also, and in between what is happening, flumes are getting trapped. Okay, so this one is what trapping flume. This is also worst because the flume is trapped in between both of them. Okay, chalo. अब इसके साथ this you should only know, I have taught you this before also. In the case if it is asking you to design the height of the chimney, so this is given by 74 qp to the power 0.27. Important is remember the unit. It is the emission in tons per hour. And this is for sulfur dioxide. The sulfur dioxide here will be in, the emission will be in kg per hour. Clear? So this is one height of the chimney. This is one height of the chimney. If in the question both particulate matter is also given and sulfur dioxide is also given, whatever is maximum you will take that value. उसके लिए आप चिमनी को डिजाइन कर दोगे. Only thing is remember the units. In particulate matter it is in tons per hour. In sulfur dioxide it is in kg per hour. That's it. Okay. और तो ये सब जनरल चीजें दी गई है कि इंडस्ट्रीज में चिमनी की व्हाट शुड बी द हाइट. दैट्स इट. हाँ, एक चीज और, टिल नाउ दे हैव नॉट आस्क्ड एवर. पानी भी खत्म हो गया. चलो लास्ट है वैसे भी. If in the case it is asking you to calculate the effective height of the chimney, so this is the height of the chimney h, जो कि आप फॉर्मूले से निकाला अभी. ये दोनों फॉर्मूले, स्टैक हाइट प्लस डेल्टा एच. ये डेल्टा एच कैलकुलेट करने के लिए दिस इज द प्लूम हाइट, जो गैसेस निकल रही है उसकी हाइट. दिस इज गिवन बाय हॉलैंड्स इक्वेशन. VSD upon U 15 plus 2.68 10 raised to power -3 PD TS minus A upon TS. बोलने में मुझे 20 सेकंड लग गए. तो ये क्या होता है, आई हैव रिटन एवरीथिंग. डेल्टा एच प्लूम की हाइट, VS इज द गैस वेलोसिटी, U विंड की स्पीड है, एटमॉस्फेरिक प्रेशर, ये जो गैस का टेम्परेचर और एयर का टेम्परेचर. सो दिस इज द हॉलैंड्स इक्वेशन. टिल नाउ दे हैव नेवर एवर आस्क्ड. अब इस साल पूछ लेगा तो मत बोलना, मैंने आपको बता दिया. क्लियर? सो दिस इज द होल थिंग. This completes your formula revision for environment. मैंने पूरे formulas I have covered which are the important ones. Any doubts? Electrostatic का भी formula बता देते. चलो. 1 minus C minus W A by Q. A is the collector area, Q is the discharge, W is the drift velocity, N is the efficiency. और कोई formula बच रहा है? और वो centrifugal force वाला mv square by r. ये लो, वो जो सेंट्रीफ्यूगल कलेक्टर वाला. बस अब पीडीएफ. अब मैं कल प्रोवाइड करती हूँ सब पीडीएफ. मुझे एप्टीट्यूड का भी करना है. चलो फ्रेंड्स, अभी 11 नहीं बजे तो हम लोग बातें कर रहे हैं अब 15 मिनट. हाँ, ये हमारी ऑफलाइन क्लास चल रही थी. चलो आज हमारी क्लास जल्दी खत्म हो गई तो हम लोग बातें करते हैं, तो अच्छी बात है ना, खत्म हो गई. चलो गाइस, यू कैन ज्वाइन माय टेलीग्राम ग्रुप. अब मैं कहाँ गए, कहाँ गया वो किसने बोला था, अनवर. और तुम 11 बजेगा. चलो कल आ रहे हो ना? एवरीबडी इज कमिंग टुमारो फॉर एनालिटिकल. डर लग रहा है? अरे यार डर सबको लगता है. एनवायरमेंट टफ नहीं है यार, एनवायरमेंट से तो प्यार करना चाहिए, इतनी अच्छी चीज है ये. नहीं है. हाइड्रोलॉजी से एक डाउट था, पूछ लेना मेरे से टेलीग्राम पर पर्सनली. अभी मैं कर रही हूँ समथिंग ऑफ एस कर्व. ठीक है. tomorrow guys we have the class of analytical aptitude at 10 am. अब तुम लोग तो सो जाओगे, अभी तो मैंने पीपीटी बनानी है बैठकर, देख रहे हो. सो स्ट्रगल. अभी तुम लोग जाओगे सो, बस शाम के 4 बजे से अभी मैं पढ़ा रही हूँ. और अभी इसके बाद I didn't had my dinner also. And now I have to make the PPTs for tomorrow class at 10 a.m. also. फॉर्मूला भूल रहे हो तो उसको लिख लिख के प्रैक्टिस करो. मैं तो लिख लिख के करती हूँ, तो मैं तो नहीं भूलती थी. और कुछ कुछ ट्रिक्स बना लेती थी जिसकी बनती है वो ट्रिक्स. इन्वायरमेंटल साइंस अच्छी थी. देखो यार, इन्वायरमेंटल भी अच्छी है. तुमने उसको उस नजर से देखा नहीं. एक बार आप उस नजर से देखो उसको, आपको उससे भी प्यार हो जाएगा. ओसीएफ रे भाई, मुझे भी सुबह टेस्ट देना है, मुझे पढ़ना है. चलो तुम लोग को सबको एनालिटिकल एप्टीट्यूड का कल की क्लास में अगर तुम लोग नहीं आए तो भूल जाना. मैंने तुम्हें क्वांटिटेटिव एप्टीट्यूड की पीडीएफ देनी है. वो डिपेंड करेगा कल की क्लास में. ये जितने लोग मुझसे पीडीएफ मांग रहे हैं ना, प्रिंस प्रबल जितने भी लोग, ये कल जब तुम आओगे तो पिछले क्लास का पीडीएफ कल मैं क्लास खत्म होने के बाद डाल दूंगी. पिछले क्लास का क्वांट वाले का. तो चीटिंग नहीं करना मेरे साथ. Is there any progress for recruitment? अभी इसरो वाली से मेरी बात चल रही है, मुझे पता चलेगा तो मैं बताती हूँ. ठीक है, आ जाओगे. आओगे तो अब मैं इतनी मेहनत से क्वेश्चन ढूंढो, टाइप करो, दिमाग लगाओ, और जो तुम ना आओ तो फिर मेरा दिल कितना टूटेगा पता है ना. वो इसीलिए तो केमिस्ट्री बोल दिया है. तो केमिस्ट्री तो लड़कियों की अच्छी होती है युक्ता. चलो guys, full syllabus course 25 and 26 already been launched, and now we'll meet tomorrow at 10 a.m. for एनालिटिकल एप्टीट्यूड. एनालिटिकल एप्टीट्यूड में क्या होता है पहले ही बता देती हूँ. वो जो डायरेक्शंस वाले क्वेश्चन, वो साउथ ईस्ट साउथ वेस्ट, वो ब्लड रिलेशंस वाले क्वेश्चंस, वो सिटिंग अरेंजमेंट वाले क्वेश्चंस, इधर से रैंकिंग 10th उधर से टॉप, तो उसमें वेराइटीज कराऊंगी मैं. ठीक है, रटा रटा है एक टाइप का नहीं. एंड टुमारो फॉर्मूला रिवीजन फॉर सॉइल मैकेनिक्स एट 8:30 p.m. ओके, चलिए. सो दैट्स ऑल फॉर टुडे गाइस. टेक केयर ऑफ योरसेल्फ. बाय बाय, गुड नाइट. अब हम लोग के पास, सोचो, हम लोग 12 घंटे से भी कम टाइम में मिलने वाले हैं. मतलब इमेजिन. ओके, तो 12 घंटे से भी कम टाइम है, बट वील मीट अगेन. सो विल मीट. थैंक यू एवरीवन. टेक केयर ऑफ योरसेल्फ. बाय बाय, गुड नाइट एंड स्टडी. थैंक यू, थैंक यू, थैंक यू.